Welcome to CS22. This is a module on data science. In this module, you will learn about data and different forms at which they can come. You also learn about different techniques that will help you to analyze your data set and also give insight to the stakeholders. Before we move into data science, let's learn what data is. Data is present everywhere and is being collected every day. For example, you make a call every day, you post your picture on Facebook, you also tweet a message on Twitter, and in fact, hospital collects data about patients that come to their clinic every time. With this amount of data, organizations focus more and more in getting insight that will help them to evaluate progress, build solutions, and make an informed decision. When they ask you to define data sets, you may define data in this way. Data is a collection of facts, and these facts may be from number, it may be from words, it may be the measurement that you have taken, or just description of things. Sometimes data may come maybe when you are writing something on papers or information that is stored on your computer. This is a graphical example of what I just talked about. As you can see, these are different ways at which data can come. It can be from information, it can be from numbers, or a fact, or observation, or measurement that you have taken. Data is fundamentally inert, which means that it has no meaning until you analyze it. And that is the main reason why everyone is looking for who can help them analyze their data sets. There are many ways at which you can collect your data. For example, it may be through questionnaire, or by interviewing set of people, or taking some observation, as you can see here. It may also be through research. For example, through research, you may want to get data by that. And in fact, you can also get data by monitoring social media. There are two types of data, and they include qualitative or quantitative. A qualitative data is the one that is being observed and recorded. In this case, it is non-numerical. For example, it is not in form of number. This type of data is collected through method of observation, from survey, opinion of people on a particular topic or discussion. Example of quantitative data include gender. As you know, gender is either male or female. Or the opinion of people, it may be strongly agree, disagree, strongly disagree, or you are neutral. This qualitative data may also be blood type. As you know, we have different forms of blood type. Qualitative data may also be country of origin. I came from Kenya, you may come from Somalia or North Sudan. This qualitative data is also known as categorical data. The reason why it is called qualitative, as I said before, is that it is being observed and recorded. As you know, when you see a man, you will know this is a man. And when you see a woman, you will know this is a woman based on their observation. Another set of data is what we call quantitative data. This is the type of data that is being measured in form of number or counts. For example, your age, the number of children that your mommy born, or the number of siblings that you have. Talking about quantitative data, we always have questions such as how many, how often, how much. For example, you may see quantitative data like the amount of money you have right now. This quantitative data is also divided into two. We have a discrete data and we also have continuous data. A discrete data is a type of data that consists of counting numbers. For example, number of students taking this course, the number of days in a year, number of females in South Sudan, or the number of calls you receive on a particular day. As you can see, this kind of discrete data will not have any decimal point. The number of calls you receive in a day may be nothing, it may be 1, it may be 2, it may be 3. And the number of students taking this course may be 30, it may be 60, or it may be 90. As you can see, there is no decimal point like 60.1 or 70.8. That is why it is called discrete data. And when you want to also identify a discrete data, you may ask the following question: can it be counted? If that data can be counted, then it's a discrete data. For example, how many books am I holding? Now, as you can see, 1, 2. Therefore, this example is a discrete data. You may also ask your question, can it be divided into smaller parts? For example, you may want to count the number of calls you receive weekly. The first week may be 5, the second week may be 9, and so on and so forth. Another type of quantitative data is what we call continuous data. This is a type of data that arises as a result of measurement, which means that they come when you measure it. For example, height. To be able to determine your height, you have to measure your height, maybe using tape rule. If you want to measure your weight right now, you have to use scale to measure your weight, to know the amount of weight you are weighing now. For example, me now, I'm weighing 65 kg. Other example of continuous data is temperature. As you know, you have to measure temperature through thermometer before you can determine the amount of temperature in a particular room or the temperature in your body right now. Now, let's see the summary of what we just discussed. In this video, we learn about data, and we also know that data can come in different forms. It may be by image, such as the kind of photos you upload on your Facebook. It can also come in form of text, such as what the tweet you are tweeting on Twitter. It may also be through recording. For example, in the hospital, they record the number of clinics, they record the number of patients that come to their clinic, and so on and so forth. And we also see that data can be divided into two. We have quantitative and we also have qualitative. And you can identify quantitative data by its nature, which is it must be numerical, that is, it must be purely number. You may also identify qualitative data through description. For example, is it red? Oh, it's soft, as you can see, through the description of the nature of the data. We also saw that quantitative data can be divided into two. We have discrete data and we also have continuous data. And we can identify a discrete data by counting. If that thing can be counted, then it is a discrete data. For example, we have 20 dogs in our house. There are 512 students taking this course, and so on. Continuous data, which is also part of the quantitative data, is that you need to measure it. For example, your weight, your height, the temperature in a room, and so on and so forth. There are two sources of data. The first one is what is known as primary data. The second one is what is known as secondary data. So let's see the difference between a primary data and a secondary data. A primary data is the data that you collect by yourself. This is the data that has not existed, only that you go there and you start generating it on your own. That is why they call it first-hand information. And this is data that is being collected by an investigator. The data collected are pure and are in the original form, and you collect it for a specific purpose. As you know, this data has never undergone any data pre-processing. That is, they've never cleaned it. You are the one that freshly collected it, and you may start working on it to achieve your purpose. Example of primary data is population census. For every country, they collect population data every 10 years. Other example of primary data is, let's say you want to collect a data set on why Africa is very poor. In this case, you are asking questions from different households. For example, number of children they have, whether they have education or not, and many other factors that may lead to poverty. Such kind of data is what we call primary data. Remember, you are the one that are asking questions, to get those data. Another source of data is what is known as secondary data. A secondary data is also known as second-hand information. This is the data that are acquired from different sources such as magazine, books, document or a report, which means that somebody has already collected the data, store it somewhere, and you also want to carry out a particular research using an existing data set, and that is why it is called secondary data or second-hand data. Now let's see the summary of what you are able to learn in this video. This video talks about data sources. As you know, we have two sources of data. The first one is primary data, which is what is called first-hand information, while the second source of data is known as secondary data, also known as second-hand information. And we can get primary data through census, through questionnaire or interview, while we have so many sources for secondary data. For example, through books, through the internet or on newspapers. Now we have come to the end of this video. Thank you for watching it. See you in the next video. Bye. Welcome back. In this video, you will learn what data science is. What is data science? In the last video, you learned about data, various forms at which it can come, and you also learned about two different sources of data. But here, now what is data science? Our knowledge of data will help us to define what data science is. Now, data science is a set of fundamental principles that helps us to extract information and knowledge from data, which means that the field of data science enables us to turn raw data into understanding, insight, and knowledge. Basically, we want to get three things out of data science, or we want to get three things by doing data science. The first one is to understand our data set, to understand what our data can give us in terms of information, and also to get the insight and knowledge out of it. So which means that data science will help us to get information, insight, which will help us to be able to evaluate our solution and to get profits. When you look at data science, you should be thinking about visualization, statistical modeling, statistical computing, data research, real-world application, that is, real-world application of data science by analyzing your data. Then, you may also view data science in these forms. It has some mathematics. You have to do some machine learning, which we do in CS 3.1. Now, who is a data scientist? A data scientist is someone that can collect, analyze, and interpret data. A data scientist uses their skills in mathematics, as I said before, statistics, and also computer science to give a shape that can express what data is saying. That is, your job as a data scientist is to apply your knowledge in data analytics to get information and insight from your data. Now you see who a data scientist is. Recently, they said that data scientists get more money, because everybody is looking for who can help them analyze their data. And since you now undergoing this training, you become a data scientist very soon after you complete this module. And from there, you have a lot of jobs available for you. Please master everything I am saying here and practice it. Then after the end of this module, you can then go out and apply your knowledge and get good money in return. What are the various strategies that can make you to become a data scientist? The first one is you must practice every class activities in this course. When you see an activity, make sure you participate in it. Data science is by doing. You must also be active in group discussion. So when we announce a group discussion, make sure you participate, be very active in it, and this will help you to become a good data scientist. The other thing you can do is you must question your data. When you question your data, then you will get meaning out of it. A data scientist always ask questions about data. And also, you must ask a question whenever you don't understand a concept. You may ask your colleagues or your mates who are also doing this course a question about a concept that you have not mastered. Or you can ask me, your teacher, a question, and I will be happy to help you learn all these concepts. The other way at which you can also become a data scientist is by visiting other learning resources that have been provided in this course. A single video will never make you a data scientist. That is why every data scientist always explore. We go everywhere. We look for different videos to master the skills and to master the knowledge and the concepts. And I will also advise you to do the same. Make sure you explore different learning resources so that you can become a good data scientist. Remember, the goal of a data scientist is to analyze data and to get insight for the stakeholder based on the data set that have been provided for you. Another way at which you can become a data scientist is to learn from your classmates. As I said, you can learn from other classmates, ask them questions on what you don't know, and I believe they will be happy to assist you. Other thing that you must know is that a good data scientist must know how to program. In CS21, you learn everything about Python. And in this module 2, we are going to use Python in analyze our data. I will be showing you other concepts of Python that you will master. For example, NumPy, pandas for data analysis, cbom package for data visualization, and everything is what you will learn in this course. So be ready to program. Never worry, programming is very simple. Remember, in the CS21, it was so easy for you, and this course too will make Python even more easier. The last thing that can make you become a data scientist is to build a project. You must build a project. After this module, go and look for any open data set, analyze it, and that becomes your portfolio. It becomes your project. So what are the various programming languages that are available for data science? There are many programming languages. You've seen how we can use Python to program, and we are going to also apply Python in this course. But we also have other programming languages such as R programming, Julia, and Scala. But in this module, we choose to use Python for data science. In this module as well, you will learn different packages for data science. And what are packages? Packages are a collection of related modules which aim to achieve a common goal. We have different packages in Python, and in fact, we have some inbuilt functions in Python, and you've seen it in the CS2 one, such as print, if else, and so on. But we also have other packages which helps us to even do more, and they include NumPy, Pandas, sklearn, Matplotlib, TensorFlow, Keras, and many more. But don't worry, in this course, we only learn 4, such as NumPy for numeric Python, Pandas for data analysis, Matplotlib and Seaborn for data visualization, and sklearn for machine learning. And you will use sklearn in the other module, which is CS31. Now, where are various cases at which you can use data science? For example, you may use data science for forecasting, such as forecasting your next year sales, the next year revenue for a company, or building customer retention. Customer retention is the ability of a company to be able to retain their customer so that they will not go to other companies. Another use case of data science is pattern detection. This is where you are detecting pattern from your data set. For example, you may want to detect weather pattern, whether it will rain today or not. Another use case of data science is recommendation. This is where you are recommending, for example now, when you are watching a film on YouTube, before you stop watching that YouTube video, you will see another video, coming up, like people that watch this video also watch this other video. That is what is called product recommendation. Another use case of data science is what is known as anomaly detection. This is where you are detecting fraud. For example, this is applicable in banking. So bank want to know whether there is a fraud transaction or not. As you know, fraud may not happen every time, but when it happens, it means that the bank is in trouble, and that is why they have to employ data scientists to help them detect all this. We also have another case study where you want to see whether the email that comes to your inbox is a spam or a good email. I know that many of you have Gmail. For example, you will see when somebody is sending you a message, sometimes it may enter your inbox or goes to your spam folder. So they apply data science knowledge in that case so that you will not get harmed. Here, we see various organizations that are using data science. For example, Facebook is using data science for social analytics, seeing different patterns. For example, they may suggest a new friend for you and all of that, and you can connect with anyone, and now you now have friends almost all over the world. We also see Amazon. They are using data science to improve e-commerce experience. Everybody knows about Uber, they help you get car at the right time. Bank of America also use data science to increase customer experience. And we see Airbnb, which use data science to improve search. In this unit 4, you've seen various forms at which data can come, such as text, sounds, images, number written on paper, or the one that is stored on your computer. We also see that data can be divided into two. it may be a qualitative or quantitative. And we said that a qualitative data is non-numerical, while quantitative data is the one that can be measured, such as height or weight. We also see that the field of data science enables us to turn raw data into understanding, insight, and knowledge. We also see different life cycle of data science projects, and they include import, tidy, transform, visualize, and communication. When you are doing data science projects, there are different phases that you must understand. The first one is importing data. You have to import data before you can get any insight from your data sets. The second phase is what is known as tidy. This is where you are arranging your data sets in order to analyze it. The third phase of data science project is known as transform. This is where you are transforming some variables in your data set by cleaning them and also removing unwanted variables or unwanted values. The first step when you are doing data science project is to visualize your data set. Visualization helps you to see what your data is saying and also helps you, to graphically represent your data. We also have another phase called modeling. This is where you are doing statistical modeling such as machine learning. And the last thing in data science project is communication. This is where you are writing a report of what you have found in your data set, and this may comprises visualization, the modeling, and all of that. So you are building a report, to show people what you are able to achieve in that data set. When you are looking at all these diagram, you will see that we have one loop here, from transform to visualize to model and so on and so forth, going like that. It's like a cycle. So which means that to understand your data set really, you have to follow all this. You keep on transforming, keep on visualizing, you keep on creating model, you keep on following all this iteration until you get the understanding about your data sets. Thank you for watching this video. See you in the other section. Bye. Welcome back. In this video, you will learn a module called NumPy. What is a NumPy module? A NumPy module is a package in Python that stands for numerical Python. It is a core Python module for scientific computing. It is also powerful to create an n-dimensional array object. This NumPy package is useful for linear algebra in Python. And in fact, most of the Python packages always rely on this. So how do we install NumPy package? In the previous module, which is CS21, you've seen how we install Anaconda distribution. So which means that if you have installed Anaconda distribution, you don't need to install this NumPy module, because Anaconda distribution has this NumPy module installed. So how do we import a NumPy module? To import a NumPy module, you will use this syntax called import NumPy as NP. As you can see, import NumPy as NP. This NumPy is the module that we want to import, and then we have the alias called NP, which means that anytime we want to use NumPy module, we will use this NP to reference it. Let's go to the lab session where we will see how to use NumPy in action. Throughout this lab session, we'll be using this folder called snippet codes for CS22. I will advise you go to the LMS and download this material. After you have downloaded it, you may want to put it in your desktop. And from there, we are going to open Jupyter Lab Notebook to access this file. So I go to my search bar and I type Anaconda prompts. So after this Anaconda prompt, as you can see, it's loading. Then you type Jupyter Lab to open or to launch Jupyter Lab Notebook. I have an error because I misspelled it. Then I type it again, Jupyter Lab. I'm going to wait for it to open a window. As you can see now, we now have Jupyter Lab Notebook launched for us. To follow along, you will have to open this file from the folder that we just downloaded. To see that folder, you will need to click on this file browser, then click on desktop. Alright, look for this snippet code for CS22 folder. You double click on it and then you will see this NumPy notebook. So if you open it now, you now have something like this. So let me close this guy because I already have it opened. To see this Jupyter Lab notebook clearly, I can hide this one here by clicking on it so that you can see everything at a glance. Now, let's see what NumPy module has to offer us. As we said before, you need to import NumPy module. And to import it, you have to say import NumPy as NP. So let me press Ctrl Enter to run it. Now, as you can see, it has been loaded. Let us now see the difference between Python list and NumPy array. Remember in CS21, you know how to create a Python list. And to create a Python list, you have to use this square bracket. As you can see, square bracket, put your element there and end the square bracket. We said that Python list can accept different data types such as a string, an integer, a float, or a boolean. Now let me run it now. With the help of this function called type, I can see that the kind of object that is saved in this Python list is a list. And these are various data types that this Python list has in store. As you can see, Ethiopia is a string, 5 is an integer, 17.9 is a float, and true is a boolean. Now let's see what a NumPy array is. A NumPy array is like a list, but NumPy array has more things to offer us. For example, let's see how we can create a NumPy array. In this case, we will be creating a Python list first. And to create a Python list, remember, you will use a square bracket and you put all your elements there and end it with a square bracket. Now I have a Python list. To convert a Python list to NumPy array, we are going to use a function called np.array. Remember, np is the alias for the NumPy package, and out of that, we want to get a function called array. So therefore, we are going to say np.array. Since np.array is a function, then we can now put our Python list inside it, and then we run it. If you look at the type of object that this one is, Python is telling us that this is a NumPy array. Okay, so let's see what is in this array. To get what is in this array, you may want to call the name that you store the array with, which is the NumPy array from list. Now I run this guy, see what I have. It's telling me is an array, which is having 1, 4, 7, 12, 1, 4, 7, 2, 12, 17 as its elements. Another way at which you can create a NumPy array is by just using np.array, a function, and then put your list there instead of creating a variable for list. You could have well just create it with just one line of code, as you can see it here. So now if I run this guy now, as you can see, I now have my array, which is 1, 9, 8, 3, and 12. One good thing about numpy array is that you can do some mathematical calculation with it. But in the previous Python list, there's no way you can create a mathematical operation with it. For example, let me just create a list. Let's call it L1 and let's put some value there. So let's say I have 1, I have 2, I have 3, 4, and 7 like that. Okay, so let me run it. Now I have run it. So let us now say we are adding 1 to it. Let's see what will happen. L1 plus 1. See what happens. I get an error because this is a list, and that is why no mathematical operation can work with a list. In this case, we need to change it to numpy array. So let's see how we can use numpy array and do our mathematical operations on it. So in this case, I will just be saying that let's call it K2 this time around. So K2 is equal to np dot array. You can press tab to autocomplete it. Array, alright, then with a parenthesis. Now put your list inside that parenthesis. So in this case, I want to say 1, 9, 1, 9, or let me just use the previous example. 1, 2, 3, 5, and 7. So I run it. See now, I have my K2 being defined. So now let me now add 1 to K2. Just say K2 plus 1. Run it. Now you can see I have my answer now. So which means that 1 is being added in every element on this array. And that is the main reason why people always use array when they want to do any scientific computing. In numpy array, we can do so many mathematical operations. For example, I have created this array which I saved in a variable, and now I want to be adding various values into that array. So in this case, I'm adding 2 with every element in my array A. So if I run it now, see what I have? I have the result. 2 is being added to every element. As you can see, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, and so on. In this case, I'm subtracting 3 from every element in A. You see, I now have the result. Also, I have this example where I'm multiplying 2 in every element of array A. So now you see, I have the result. Here, I'm dividing every element by 2. Now, I have the result, as you can see. So in the last example here, I want to get the cube of every element in array A. That is why you can see this is an exponential operator, which means that we are raising every A to 3, every element in A raised to power 3. And if you run it now, I have the result. You can see that numpy array is interesting, right? It's very simple. The first thing you must learn is learn how to create your array by using this function np.array. And inside that function, you put your list there, and that's all. So let's see another example. In this example, I'm creating 2 arrays. The first one is array A and the second one is array B. So let me run it. I have my result now. You will note that I have the same elements in array A and array B, and from that I want to get a result of A plus B. So if you run it now, so what this will do is that it will add every element, because this will be like element wise. 5 plus 3 is 8, 2 plus 2 is 4, 7 plus 4 is 11, and so on. In another example here, I am subtracting B from A. So if I run it now by pressing Shift enter, you can see I have my result. Here I am multiplying those elements by each other. Now you can see I have the result. So array is very simple. The same thing with addition, or the same thing with division. As you can see, this is the divisor sign. Now I have my result. Now if I run it now, as you can see, I have my result here. So the other one here is where I'm using modulus. Remember, modulus is the remainder when you divide a number by another number. So if you divide A by B, the remainder for each element is what we have here. Very interesting. This one, I am squaring every element of B by A and I get the result. We have now come to the end of this video. We will resume back to see how we can index NumPy array. In the last video, we have this NumPy array A, and as you can see, this is the array A, 5, 2, 7, 4, and 12. Let us see how we can get the square root of every element in this array. So here, we are going to use np.sqrt, and this will give us the square root of every element in this array. Now let's run it, and this is the result. As you can see, the square root of 5 is 2.23 and so on like that. Now let's see how we can index a NumPy array. In CS21, we look at how we can index Python list. Since you know that Python index starts with 0, the same thing applies to NumPy array. So let's see. I have this array, that is 1, 2, minus 1, and so on. So I run it, I print the result, and I have this. So let's see. You can see if we have this as our array, then the index, which is the first number here, will be 0. The index of 2 will be 1. The index of 10 will be 9. Since Python index starts with 0, we keep on counting it until the end of the array. Okay, so now let's use this index to get our element from the array. So to get the value of 1 in this array A, we are going to use its index. So in this case, I will just say A square bracket 0, and you see I have the result here. So if I run it again for this index 3, I'm going to get 4. Okay, and let me create a new cell. And let's say I have a, let's see the index of let's use 8 as index. As you can see, our value that we return will be 9, because 9 has index 8. So if I run this guy, see what I have 9. Okay, we can also replace the value of an array, okay, using its index with another number. So in this case, I'm going to replace the value that has index 2, which is minus 1, with 5. So if I run it, see what I have. Now if you look at the new array now, you will note that minus 1 has been replaced with 5, because that is exactly what I did here. Now you see how we can index value of an array by using its index. Sometimes we may want to get values that has more than one index, and let's see how we can do that using array slicing. Remember, array slicing or NumPy list slicing starts with this: the start number and the stop. And if we omit the start number, then that start number will be 0. And also, if we omit the stop, then the end will be the last index of that array. And also, if I have index 1 to 3, remember what I will now get is 1 and 2, because Python will be subtracting -1 from the stop here if it is written in full. So let's see it in example. I have this array that is 2, 4, 6, 5, 8 and 9. Let me run it. Remember, it is not necessary if you don't put print here, you will still get your result. Okay? If you don't put print, you have array, but if you put print, it will only print it in a good form. It removes the array, although it's still an array. Because if you look at the type here, you see type A, you still get an array, as you can see. Okay, great. So let's also define a variable B which slices elements from array A. Now in this case, see what we are doing here? We are saying from 0 to 2. So inwardly, Python will be doing something like this, 0 and 1. Because if you make it in full like this, Python will subtract 1 from the last number here, which is 2. And that is why we have 1 here. So then we have 0 to 1. Now let's run it. As you can see, we have 2 and 4 because 2 has index 0 and 1 has and 4 has index 1, and that is why we have this. Let's see another example. So in this example, I'm defining an array called x, and in that I have this, that is 5, 8, 9, 2, 4, 6 and 5. So let me run it. So here I want to print, I want to slice values or index from 1 to 3. Remember, in this case, I will be having something like 1, 2. Since 3 will not be there because 3 is the last number, so Python will subtract 1 from 3. And here, I will now have 2. So let me remove my comma. So in this case, I will be looking for the index 1 and 2. Then I will now get their values. Look at it here. 8 has index 1 and 2 and 9 has index 2, and that is why we have both 8 and 9. That is why we now have 8 and 9 being returned for us. I hope you are mastering it now. So in summary, if you did not put any value at the starting point, Python will see it as 0, and in that case you now have 0, 1 and 2 because the stop value is 2. You see here, you did not have the endpoint. So what Python will do is to start with 1 and then make the endpoint to be the last index of your array. So let's see it in example. So in example 4, I have this. I have my array and I'm asking, starting from 1 to the end. You can see that the index 1 is 4 and Python will now see it from 4 to 5, and that is why we have this. Okay, so let's see this one also. Remember, all this is what you learn in CS21, where you are slicing NumPy, where you are slicing Python list. So I have my array x, and from there I'm getting, starting from 2 to the end, and here is 2, so I will have 6 to 9, and that is the reason why I have this. Okay, I believe you can do all this. Okay, so one other thing is that it depends on how you put it. So let's say I have this array A and array B. Okay, this array A is from 2, 1, 7, 4, 6, 8 and 3, and the array B is from 0 to 7. Remember, this will be from 0 to 6, and that will be 0, 1, 2, 3, 4, 5, 6. Okay, and that is what we have as B. And if I run everything like this, I will have each of these being printed here, which is giving us the same thing. Remember, this is our array A. We are getting B from A, that is from 0 to 6, That is what give us our B, and the B is what got printed here. And also for C, we are getting it from A, but in this case, as you can see, the starting point has been omitted, and in that case, it will be 0. So we are now having from 0 to 6. As you can see, that is why we have all this. So you may want to play with it for you to understand it better. We have now come to the end of this video. In the next video, we will see different attributes of a NumPy array. There are many attributes for NumPy array, and they include shape. Shapes indicate the dimension of an array. We also have size, which returns the total number of elements in an array. Then, another attribute for a NumPy array is called dtypes, which return the type of element in that array. Let's see an example. In this example, I have a NumPy array called even array, where we have even number from 2 to 16. Okay, so if I say even array dot shape, then I will get its shape, which is 8. Let us run it. We have 8 here because this kind of array is like one-dimensional array. That is why you are seeing the number of elements here separated by a comma, because this is not a two-dimensional array. To get the size of an array, to see the number of elements in an array, we use this attribute called dot size. So let's run it. Dot size. Remember, you may not want to put print and it will still work. For example, the name of the array, even array dot shape, to see the shape of that array. This attribute has no parenthesis. It's just like this, shape, and you get your result as 8. The same thing with size. The size will give you the number of elements in that array. So in this case, I'm having this even array, then dot size, which is the attribute I'm interested. So I have 8. And to get the kind of data type that is in this array, I may want to use even array dot dtype, which will give me the kind of data type that it is. So let me do it here without print. Even array, that's the name of the array, dot dtype. Dtype, and you run it and you get result. Now you can see this is an integer array. Let's see example 2. In this example 2, we have this array called sum array. So let's run it. Now we have it. So to get the shape of this array, remember this is a one-dimensional array, you can just say sum array, the name of the array, followed by the attribute called dot shape. So I have this, and you can see 25, comma, which means that it's a one-dimensional array. And to get its size, you just include dot size to the name of the array. Then you can see we have 25 elements in this array. Let's see another way at which you can create a NumPy array. In this case, we will use what is called a range. A range function is similar to the range function that we have seen in CS21. So let's see. Let's say you want to get an array from 0 to 5. You may want to say np.range and put 5 inside the parentheses. As you can see, we have the result as 0 to 4. So this a range will subtract 1 from here and you get the result as this. We also have another one, np.arange 10. When you put 10 here, then it will start from 0 and end result as 9. Now we have this. Since a range works like range in Python, okay, it actually has its own argument like this: the first, the starting point, the end point, and the increment. So here the starting point is 1, the end point is 10, and the increment is 2. Now let's see. So we have 1 here, and for every element it will add 2 to it. You can see 1, 3, 5, 7 and 9. Since our array is not up to 10, because if you add 9 to 2 you get 11, and we are saying that we are stopping at 10. That is why we have this guy here. So let's see another example for a range. Remember, you have to say np dot a range. Okay, here I want to have number from 5 to 100. Then the increment is 25. Run it, and now you get the result. Okay, you can see 5 plus 25 30 plus 25 55 plus 25 80. So if you add 80 to 25, you will get something like 105. And since 105 is not up to what we are looking for, that is why it has to end it at 80. Another way at which you can create an array is by using what is called linspace. What linspace does is that it will evenly spaced number over a specified interval. So in this case, I want to generate number here, so I'm saying, okay, give me a number from 0 to 10. As you can see, 0 to 10, and just do it in this way. So the total number that we are looking for is 3, but spread the number from 0 to 10, and that is why we have this. Let's see another example. So here, as you can see, lin space 0 to 50, give me 10 number from 0 to 50. So if you run it now, you now have the result. And if you count it, you may want to count what is the result. For example, let's say copy this guy, copy it, Ctrl C, open a new cell, type len, close it and do like this, and you get the result. You can see 10, because this is the space at which you want to distribute our data. We are saying that distribute it from 0 to 5, just give me 10 numbers out of 0 to 50. So this should be useful when you are creating data sets. A simple form of multidimensional array is what is known as two-dimensional array, which is the same as a matrix. And to create a simple two-dimensional array in Python, you are going to use list of lists. For example, this is a simple two-dimensional array, as you can see it here. So you will view this one as the first array, this one as the second array, this one as the third array, and you put all of them in each list. So let's see how we can create this two-dimensional array. So to do that, what we do is to first of all use is equal to np.array to create your array function. Array, as you can see, you close the parentheses and you put a list there. As you can see, first of all, you put square bracket, end it with another square bracket. Then inside that square bracket, you now start creating list for each of these row. So I will start with this. I will open this one here, as you can see, then type a list, that is 1, 2, 3, as it is displayed here. When you are done with this row, you may want to close the square bracket, which is this guy here, and separate it with a comma. Then you begin another list. So here you will put 4, 5 and 6. When you are done with that list, then you leave the square bracket, separate it with a comma, and then create another list. In this case, I will put 7, 8 and 9 in this list. 7, 8 and 9. And when I'm done with all the elements here, then I run it. As you can see, now I have my A. So to see what is inside this A, I can just call it A and I run it. Now I have my array. You may want to know whether this is an array by using type. As you can see, type A, run it, you get the result. Now it's telling you this is a NumPy n-dimensional array. Remember, in the previous video, we considered 3 attributes of array. The first one is shape, followed by size, followed by dtype. So let's see the shape of this array. So to get the shape of this array, you may want to use a dot shape. For example, I can remove my print, although if you use print it will still work. So to get the shape of this array, you can just say a dot shape, run it, it gives you 3 by 3. So 3 by 3 here means that you have 3 rows, and these are the rows: 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last 3 here is telling you that you have 3 columns, and the columns are 1, 4, 7, which is the first column, 2, 5, 8, which is the second column, and 3, 6, 9, which is the third column. We can also use um size to get the number of elements in this array by using a dot size. As you can see, a dot size will give you the number of elements, and if you count it 1, 2, 3, you see that all the elements in this array are just 9, and that is why this returns 9. The last attribute for this array is what is known as dtype, and you can check it by using dtype. Run it, it will tell you that all the elements in that array has integer, or they are integers. Let's see how we can create this other example. Here we have an array called another array which has all this. So we may want to create it. Remember, to create it you have to say np.array, and then you put this square bracket to specify that you are putting a list of lists inside it. And after that, each of these elements 5, 6, 7, which is in the first row, you will put it in a list, which is this one. When you are done with the first list, you separate it with a comma and you start with another list, which is 4, 2, 1. After that, you specify another list, which is this one, 3, 7, 1, and then you run it. Now you can see that we have created this another array. And to get the shape, you can just say dot shape, and you get it is 3 by 3. To get the number of size, you may want to run it now. As you can see, now you have 9. You may be asking, why are we having 3 by 3? Of course, you can create another array which is not a 3 by 3 dimension. For example, let's say I have b to b, this one here, I say np dot array. All right, then I can put a list of lists there, just 2 lists. That's how I want my list to be. So here I can just do like, okay, let me close this one, and inside it let me put another list here. So here now, let's say I have 4, 6, 8. Then I'm done. Then I create another list. Then here I'm having 2, 3, 1. This is what I want. Now let me run it now. Okay, it works. So we want to create a cell to see what that array B looks like. Now you can see we now have this array B. And to get the shape of this array, you can just say b.shape, b.shape. Now you have it. This is a 2 by 3 array. Now let's see how we can index an array which is a 2-dimensional array. So remember that Python index starts with 0. And since 2-dimensional array has both row and column, then when we are indexing it, we have to specify the row position that we are looking for and the column position that we are looking for. Here is an example. So this one here, as you can see, this is the first column labeled as C0. C means column. 1 here represent the first column. 2 here represent the second column. So we are having 0 here because the index of Python starts with 0. Okay, so here now we have 1, 2, 3, which is the first row. Okay, and that first row will be noted as 0. So this one here, which is the second row, the index here will be 1, as you can see. And this one here, which is the third row, we have R2 to define the position. Okay, great. So let's create a matrix that looks like this. Now I have it now. As you can see, I've created it. Now let me now get this index 2. As you can see, 2 is here. So the first thing to do is to have, because an array is a two-dimensional array. So we have to specify the row position followed by the column position. The row position will be here and the column position will be here. Now if you look at 2 here, you will see that this 2 here is in row 0. As you can see, row 0, row 0. While 2 here is in the column 1. As you can see, this is column 0, this is column 1. So therefore, I will say 0, 1, 0, 1. So let's see, 0, 1. When you run it, you get 2 because 2 is in row 0 and column 1. So let's see how we can get 6 here. So to get 6, let me create a new cell. To get 6, I will first of all use the name of my array, which is A, followed by a square bracket, and then I will put the index there. So if I want to get 6 here, this 6 will be in row 1. As you can see, row 1 and then column 2. I just say 1 column 2 and I will get 6, as you can see it here. So let's see how we can get 4. The 4 is here. Then we just say 1 column 0, 1 0. As you can see, R1, 4 is in row 1 and 4 is also in column 0. So I will just specify 1 comma 0, and that is what I have here, 1 comma 0, and I get my 4. So let's see another example how we can get the value from two-dimensional array. So here I have this matrix. As you can see, I have this matrix. Sometimes I can call it matrix and I can also call it array. So I have this matrix 2, 3, 4, 6, 7, 8. So if I specify this, it means that in the row 1, this is row 0, 2, 3, 4 will be in row 0, and 6, 7, 8 will be in row 1. So since I need row 1, which is this guy here, and column 2, this is column 1, 2 and 6 will be in column 0, 3 and 7 will be in column 1, and 4 and 8 will be in column 2. So since I need 2, I will just do this one, and in that case, it will extract 8 for me. So let me run it. Now as you can see, you have 8. Other thing, for as you know that array is mutable, you can change the value of an element with another element. So here I'm changing this value of 8 to 20 by getting its by using its row and column position. Then the value of this 8 will now be taken for 20. So let me run it now. So if I do it now, as you can see, it has replaced 8 here with 20. So let's see another example. So let's say I have, remember this 3 here, I want to change it to 9. So what I will do here is I just say A, okay. So then let's specify the row position and the column position. Since I need this 3, the row position is 0, as you know. I just put 0 here, followed by the column position. The column position of this 3 is 1. Let's see, this is column 0 and column 1. So if I put 1 here, see what I have. It gives me 3. Now to replace this 3 with 9, I can just say it's equal to 9. When you run it, okay, it has replaced 3 by 9. But how can we see it? Just call the name of your array, which is my A. Then if I do like this, A, now run it, you get your result. As you can see, the 3 here has been replaced with 9. That is how to, number 1, index an array and to substitute its value with another value. Now, with the attribute, remember we have the attribute shape, attribute size, and attribute daytime. So this is exactly what we are doing here. And also we want to see how we can slice it. So if I run this, I have my array A, which is 2468 and 0541. I believe that you know how you can create this array. So let's see its shape. Its shape is 2 and 4, as you can see. Now let's see what this one is doing. So we are saying 0 2. Remember, we start with 0 and we end with 1. While this one we start with 0 and end with 2. So here we are saying we need 0 and 1 row. 0 and 1 row. This is row 0. This is row 1. Very good. And after that, here we need column 0 to column 2. Remember the last one, 3, you subtract 1 from it, so making 2. It now be from column 0 to column 2. This is column 0, this is column 1, and this is column 2. So in that case, I will be getting 246054, and that is exactly what I have here. As you can see, 246054. So let's see what this one is doing. Here I want to get array B from array A, and in this case here, as you can see, I have A with this square bracket. Since this is a two-dimensional array, then I want to specify saying that from 0 to 2, and this one here, because I did not specify anything, it means that it will extract all the columns for me. So let me run it now. You can see I have this one here. So what is the interpretation? Interpretation of this one is that it will start from row 0 to row 1. Remember, this is having the end as 2. So subtract 2 from 1, you get 1. So this will start from 0 to 1 while we are taking all the columns. So remember, this is it. Row 0 and row 1. So it will take everything, and then let's see its column. The column is that we are taking everything back, and that is why we have all this. And if you look at what we have in this array B, it's the same thing with what we have in array A. So which means that this one is showing us how we can slice our two-dimensional array. So this one as well is like, as you can see, we did not put anything here, only that we specify column. And when there is nothing except the column, it means that we are getting all the rows. And for this one here, it means that we are getting all the columns. And if I run it now I have everything. We have now come to the end of NumPy array. So in this video, we see how we can create a two-dimensional array, how we can slice its index, and we also saw various examples that can help us to know how to create a NumPy array in terms of two-dimensional array. We have now come to the end of this video. See you in the other section. Bye. Welcome back. In this video, you will learn how to analyze dataset. Before you can analyze dataset, you must know pandas, and that is what this video is all about. What is Panda? Panda is a popular package in Python for data science. It's a powerful package which has flexible data structure that makes data importing, data cleaning, and data analysis very easy. Panda is an open source data analysis and is a manipulation tool that is always used with many numerical tools such as NumPy, SciPy, Matplotlib, and Seaborn. You can think of pandas as an extremely powerful version of a spreadsheet like Excel or Google Sheets. But these pandas has more features that you are going to see in this video. Now let's see how we can install pandas. If you have Anaconda distribution installed on your computer, you don't need to install pandas because pandas is already pre-installed in Anaconda. Now let's see how we can import pandas. To import pandas, we are going to use this syntax: import pandas as PD. Remember, when we were importing NumPy, we say import NumPy as NP. So for pandas, we are going to say import pandas as PD. This PD is an alias for pandas. So which means that anytime that we need any pandas function, we are going to be referencing PD. There are two components of pandas, and they include series and data frame. A series is like a column of a data frame, while a data frame is a combination of many series. Let's see an example of a series. Remember, a series is just a column in a data frame. Here is an example of a series. This is where we are having a column called gender. Here is another example of a series where we have a column called country. And in that column, we have different countries such as Uganda, Ethiopia, Rwanda, Somalia, and so on. Here is also another example of a series. Here we have a column called age. As you can see, this is a column age. And now, let's say that we have many combinations of gender, country, and age in one structure. In that case, we may be referencing data frame. A data frame combines many series all together. And that is why we say that data frame is like an Excel spreadsheet where you have your data set in form of a table. And the table we have columns and rows. Here, as you can see, we have columns like gender, we have columns like country, and we have columns like age. And here are the different rows that we have. As you can see now, since Python has its index as 0, now in this case, we have row 0, which is the first row, row 1, which is the second row, and so on, up to 10th row in this data frame. Now, let's go to the lab session where we will see how to use pandas. In this lab session, we'll be using Pandas 1 notebook. I will encourage you to open this script so that you can follow along with me. In order to see my screen clearly, I'm going to hide this by clicking this folder. Now I have my script. The first thing to do is to import pandas, and then you say import pandas as PD. Now that we have imported pandas, remember that we have two components of pandas, which are series and data frame. This is how series look like, and here is data frame. So let's see how we can create our first series with pandas. In this case, we are going to create a series for gender. So I'm creating a variable called gender. Then to create a series, you have to use a function in pandas called pd.series. pd.series. This is a function, and then you put a list of your variable inside this. As you can see, our list here will contain all these genders, which are male, as you can see, female, 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 male, female, male, female, male, female. And this is what we have inside the list. As you can see, we put all this inside the list with the help of pd.series. And if you run it now, you see that you now have series. And to see this kind of object, we may want to use type of the variable. As you can see, we say type gender. Now, when we run it, we can see that here is what we call pandas series. Pandas series. Let's see how we can create the second series called country. I'm going to do the same thing by calling pd.series. I'm saving the result into country. As you can see, then all the countries inside this diagram, which are Uganda, Ethiopia, Rwanda, Somalia, Sudan, Kenya, Uganda, Kenya, Somalia, Rwanda. I will put all of them in this list. And that is what I have here. As you can see, And when I run it, I have this series. And you can see that this is type series, as you can see, call series. So the last example where we'll be creating a series for age is what we have here. And we put all the ages inside a list. And we have this like this, as you can see. When you run it now, then you've created a series called age. And as you can see, here is the series. The type of the object in a variable age is called a series. Now that we have understood how to create different series using pandas, let's now see how we can create our first data frame. Pandas data frame represent dataset in form of a table, and the table will consist many rows and columns. Here is an example of data frame. As you can see, we have more than As you can see, we have 3 columns, and they are gender, country, and age. And you may see this as pandas series. The gender here is a pandas series. We also have another series, country. We also have another series called age. So to create this data frame, we'll be using what is called a dictionary. In CS21, you learn how to create a dictionary. So we are going to create a dictionary for this data frame before we can use pandas data frame to convert our dictionary into the real data frame. So let's see how to do that. As you can see, the first thing to do is to first assign our variable. And in this case, our variable will be registration dictionary. This is where we want to save our result into. And we will now represent all this as dictionary. If you can still remember what a dictionary is, remember that dictionary is a pair of key stroke value. A dictionary is key to value relationship. So which means that this gender will become a key and all this will become its values. I can also see this one. This will be another key and here will be its values. We also represent age as a key while all this will be its value. So let's see how to do that. So we are going to use this curly bracket. Okay, you open the curly bracket and you start putting all the keys and values into it. The first one here is our key. As you can see, the key here is a string, and that is why we put it in quotation, followed by a list that will store all these values. As you know, this is our list. Having done that, then we put comma at the end of the list to begin another key, which is country. As you can see, now we have another key called country, and we have this one as its values. When you are done with that, then you create another key again, which is our last key. In this case, our key is called age, and here its values. When you are done that, then you run it. Now as you can see, we now have a dictionary, and you may want to examine whether it's a dictionary or not by using type with the name of the variable. So here you can see that this is a dictionary. So having done that, we now use pd.dataframe and we now put our variable inside it to now get our main data frame. So let's do it. As you can see, this stored into this, and we are now calling this guy again to give us its output. Now, as you can see, we now have a data frame. This data frame has 3 columns and we have 10 rows, as you can see. One good thing we can also do is that when we are creating our data frame, we may want to specify the name, that is the column names, in that order. As you can see now, I have an argument in this data frame called columns, in which we are now specifying our columns in that order as they are in the dictionary. You can see the first one is gender, followed by country, followed by age, and that is what we are putting here. and we get the same result. This is very important because when you are doing advanced data frame, you may want to specify your columns there so that it can be in that order, and that is what we did here. Let's see another example where we are creating a data frame. In this case, we are creating a data frame for COVID-19 dataset. So here, as you can see, we have how many keys? 1, 2, 3, 4, 5, 6. We have 6 keys which will represent our columns, and then here are the values for this key country, and here's another values for this key called total cases. Having done your dictionary, then you can now put pd.dataframe so that you can now get pandas data frame. Now, as you can see, here's our dictionary, and here is where we are specifying our columns in that order. Remember, our columns will be the keys in our dictionary. So if you are able to do this, run it, you get your data frame as it is. As a data scientist, you may want to see the overview of your data set, and therefore we have many attributes of pandas data frame that can help us do that. The first one is called .head, which will help us to see the first 5 observations in our data set. So let's see. You can see this is our data set registration data frame that we created previously. And now to see the first 5 observations, we are going to say .head. Okay, this .head is an attribute of pandas data frame, and you have to put bracket there. You open the bracket and you close the bracket. So if you run it now, you can now see the first 5 observations. Another attribute of panda data frame is what we call .tail, which helps us to see the last few observations. So in this case, it will show us the last 5 few observations. Now if I run it now, as you can see, I have my result as it. Let's see another example where we'll be using COVID-19 data to see the first 5 observations. Remember, to get the first 5 observations, you use the attribute called .head, and to get the last few observations, you use the attribute called .tail. So in this case, I'm running this, and I can see my first 5 observations, and with the help of tail, I will see my last few observations. All these head and tail, they have one argument inside it, although the argument is optional. For example, here, if you just specify 3 here, you only see the last 3 observations in your data set. And for here, if you put 7 here, you will see the first 7 observations in your data set or data frame. So if I say data set, I'm saying data frame. Please don't be confused. When you are using head or tail, the default value for head is 5, while the default value for tail is also 5. Please save that in your notebook. Another way at which you can get information about our data frame is by using .info. .info is also an attribute of pandas data frame. So what .info will do for us is that it will give us the data type of each of our columns in a data frame. For example, let me run this. Remember, I have created 2 data frames. The first one is called registration data frame, while the second one is called COVID-19 data frame. I will be using all these 2 data frames throughout this video. Now I run this, I can see that the country column is an object, which means it's a string data type, while gender column is also an object type, which is also called string data type. In pandas, whenever you see object, it means it's a string data type. As you can see here, we have age. Age is in 64, which means it's an integer data type. Let's see the information about our COVID-19 data frame. So I will do that by first of all call COVID-19 data frame, COVID-19 data frame, then press dot. To get auto completion, you may want to say IN and press tab. It will suggest what you are looking for you, and from there you can pick info. And remember, this is a method of the data frame. You have to put parentheses inside it. When you run it, you now get everything. That is, you get the information about your data frame. Here we have 6 columns. The first one is country, which is a string data type or object data type, while the rest of the columns are integer data, they are integer data type, as you can see it here. Another method or attribute of a data frame is what is called shape. Remember, when we were doing two-dimensional array, we use dot shape, which gives us the number of rows and number of columns in our array at that time. So the same thing applies to a data frame. In this case, it will tell us the number of rows and the number of columns in our data frame. So let's see. Remember, for dot shape, there will not be any parentheses. Now, the result of this one is 10 by 3, which means that we have 10 rows and 3 columns. Let's see it for the other data frame, which is COVID-19 data frame. Remember, COVID-19 data frame has COVID-19 for each country and their cases. So here now, we now say that we have 8 rows and 6 columns. Sometimes, you may want to see the index in your data frame. Remember that index is your row position. So to see the index, you can just say dot index, which will give you the number of index in your data frame. So here I can just run it. As you can see, it's telling me range index, which starts from 0 and end with 10. That is, our index starts with 0 and end at 10, as you can see. If you remember how index works in Python, when you are saying 0 to 10, it means that you will start with 0 and stop at 9. Remember, the last one will be subtracted with 1, and the remaining one will be what we have here, and in this case it is 9. Sometimes you may want to see the columns in your data set, and we have an attribute called dot columns to help us do that. You can just say registration data frame dot columns. Now, as you can see, it listed all the columns in my data frame. In this case, I have country, gender, and age. So let's see columns in our COVID-19 data frame. The column in our COVID-19 data frame can be gotten by using dot columns attribute. Dot columns attribute. Remember, this one, you don't need to put any parentheses there. If you run it now, you now see all the columns in your data frame, and they are country, total cases, total deaths, total recovered, active cases, and population. Welcome back. In our previous video, we created a data frame called registration data frame. As you can see, this is what our data frame looks like. Now, let's see how we can select a particular column from this data frame. In this case, I want to select a column called country. To do that, I will use a square bracket. Remember, when we were doing list and numpy array, we saw how we can extract a particular element from that by using a square bracket. The same thing also applies to data frame. So let's see how we can select that series from this data frame. So in this case, I will be saying registration, then put a square bracket and put the name of your series that you want to extract from it. In this case, it is country. Now I run it. To select another series, okay, I may want to say registration df, okay, put it in square bracket, put it in string, and say age, for example. Let's say age. And here I have my age. Another ways at which you can select a series from a data frame is by using the period method. One problem about the period method is that there should not be any space within your column name. For example, let's say I want to get gender out of my data frame. I can just say dot gender. I run it, I get my result. Remember, I can also say this by using the second method. I will still have it. Let's use the dot period to get age series out of the data frame. In that case, I will be saying registration df dot age. Alright, as you can see, I now have my age. Let's use another data frame called COVID-19 data frame. So here I have my data frame. To use a dot period here, it means we get an error if you do it for total cases. The reason is that the dot period has one condition. There must not be any space in that column name. Since there's a space here, then I will get an error. As you can see, it's saying invalid syntax. To correct this error, we use another method, which is our square bracket, and that is what I have here. So if I run it now, I get my results. Let's see how we can select more than 2 columns in a data frame. In that case, I will be using square bracket because it is only the square bracket that can work in this case. And to do that, the names of our column that we want to extract from data frame, we will put it inside the list. So let's see it. So here, as you can see, a list that has the variable names that I want to select. If I run it now, I have this. Okay, let's see another example. In this case, I want to select just 3 columns, and they are country, population, and total cases. Remember, to get all this, you have to put it in a list, and that is what I did here. So if you run it now, you get your results. Let me show you another example. In this example, I want to select country and population. Remember, to do that, you have to say COVID-19, call the name of data frame, which is COVID-19, followed by a square bracket, and put those variables that you want to extract in a list. And in that case, I have country and population. You put population there, population, and you run it. Then you get your result. In this video, we will see different operations, such as how to rename our variable in a data frame. Let's say that we have our data frame, which is COVID-19 data frame. And as you can see, we have all these series, such as country, total cases, total deaths, total recovered, active cases, and population. To rename any of these variable, what you will do is that you will call the dot rename in that data frame. That is, you just say COVID-19 underscore data frame dot rename. And in the dot rename function, you will put a key. That is, you will create a dictionary where the existing variable will be the key and the value will be the name that you want to rename it with. For example, let's say that I have this COVID-19 data frame. I call out dot rename because that is the function that will help me to rename my existing variables. So here, there's an argument called dot columns. So you may want to specify that, say columns is equal to, then in that, you now create a dictionary. This is a dictionary. In this case, our existing variable is total cases, which you put here, and the value that you want to replace it with is COVID-19 cases. So we also want to replace total death here, which is this one, with COVID-19 death cases. Now, if I run this now, see what I have. I now have my rename variables such as COVID-19 cases and COVID-19 death cases. Let me show you another example. So here, I want to rename total cases and total death with COVID-19 cases and COVID-19 death cases. So just the same thing that we did here. If you look at this one here, we get our result instantly. But there's another argument called in place, and you can specify it to true, which means that it will replace our existing data with this. Now, if I run it now, as you see, there is no result. I will only get result if I call my data frame back. Now, as you can see now, I now have my data frame back. In which case, that my columns, total cases and total death have been replaced with this COVID-19 cases and COVID-19 death cases. Let's see another example where we'll be using the dot rename attribute to rename our gender series into sex series. So let's see it. Here is our registration data frame. As you can see, we have country, gender, and age. And in this case, I want to rename this gender to sex. What I will do is to call the dot rename. For example, I have this registration data frame dot rename. Okay. Then I will call that argument called columns. Then put it in form of a key. Alright. The variable that I want to replace is gender. Say gender. Since this should be my key, I put a key here. Okay. Followed by a colon. Then you now put the name that you want to replace it to, which is sex. So in that case, I have sex here. Right. So if I run it, I will get my result as this. But let's say that I want to replace this data frame, okay, to the last one. In that case, I can just say in place is equal to true. It's equal to true. And I run it. As you can see, it has replaced the former registration data frame. So if I now call this data frame again now by saying registration data frame, then I have this. As you can see now, from gender here to sex. That is how to rename a variable or more variables in a data frame. Let's see how we can add another variable to existing data frame. For example, I have this COVID-19 data frame, and let's see the first 5 observations. Now, remember, to get a series from a data frame, we have 2 ways to do that. The first way is to use the square bracket, and the second way is to use the dot period. But I said that the dot period is not good because once your variable name has a space, then you will get an error. So let me just tell you that keep on using the square bracket and forget the dot period method. When I say dot period, I mean something like this. Let's say COVID-19 data frame dot country. Here is the dot period form, which I don't want you to be using. As you can see, I get my result, but once there is a space in the column name, then this will return an error. Let's see it here. COVID-19 cases. As you can see, there's an error. But if I don't use the dot period and I use the square bracket, okay, this will return exactly what I am looking for. Remember, I can put this guy in quotation. Now I have my result. So we use this method okay, to add additional variable into our data frame. In this case, I will have something like this. Look at it here. Because this variable is not there before, okay, I will use this fatality rate. That is my new variable, and the formula that will create our variable fatality rate is what we have here. In this case, we are using COVID-19 death cases and COVID-19 cases to calculate fatality rate. As you know, since we need this variable, we have to get it from this data set. So therefore, this will give us COVID-19 death cases over, then we have this. Remember now, we are getting fatality rate from death cases and COVID-19 cases. So if I run this now, see what I have. It has stored the value into this. And now, to get what is being stored in fatality rate, you will need to call your data frame. And if I run this now, as you can see, I now have my fatality rate, which is death cases over COVID-19 cases. And now, and that is how to calculate and that is how to get a variable from existing variables. Let's see another example. In this example, we want to calculate discharge rate. Discharge rate is the proportion of people that recover from a disease compared to the total number of people that have that disease at a particular period of time. So the formula for discharge rate is total recovered over COVID-19 cases. Remember, we are creating this variable into our existing data frame. So I will have to do this COVID-19 data frame, and this will help me put that result into this variable called discharge rate. And the formula to help us do that is this. Remember, is COVID-19 recovered over, this is over COVID-19 cases, and that is how the formula is. And if I run it now, I now have a new column in my data frame called discharge rate. So if you run this now, you will see that you now have another variable called discharge rate. So one good thing when you are creating additional variable is that you must know how to select the existing variables that will help us calculate that additional variable in your data frame. And it is very simple. You just extract the column like this and the other column like this, and based on the formula, then you get your new variable or new series. Let's see this one before we finish this video. In this one here, we want to see how we can remove an existing variable from a data frame. For example, let's see our registration data frame. In this case, I want to see the first 5 observations in my registration data frame. So let's run it. Now, as you can see, we have that. We have country, sex, and age. To remove a particular variable from a data frame, you will use an attribute called drop. This attribute is from pandas. You just say your data frame dot drop, and in that case, you will put the country that you want to remove, or the series or the variable that you want to remove. You will put it here. And there is one important argument, which is axis. Since the series is a column of a data frame, you are going to specify axis is equal to columns. Remember, columns, which represent the axis that you want to remove. And for a series, the axis will be column, while for rows, the axis will become rows. Many a time, people always use columns because they want to remove a particular variable from a data frame. So let's see how to do that. What I want to do here is that I want to remove this variable or this series from my entire data frame. Remember, what will help us to do that is the dot drop attribute. So I just say I can clean this so that I run it afresh. I just say dot drop. All right. Then you put this there and you put the series that you want to remove. In this case, I want to remove country. Okay. Then you specify axis. You just say axis is equal to columns. That is column. That is, you want to remove country and you run it. As you can see, now that you have removed country, what we are left with now is two series or a data frame which has sex and age. Let's see another example. In this case, let's say I want to remove the age series from my data frame. Remember, to do that, you can just say registration.drop and you specify the column that you want to remove. Let's say I want to remove age. Then you put it there. Since axis will always be columns, you just say columns and you run it. Now that you have run it, remember you've saved the result into this variable, that is registration df drop. So to get what is saved in that variable, you are going to rerun the variable name. So if I run this guy now, I now have the resulting data frame. Let's see another example. In this example, we'll be using COVID-19 data frame, and this is how the data frame looks like. So let's say that I want to remove more than one column. Let's say I want to remove active cases and population from my data frame. Active cases, this is active cases, and this is population column in my data frame. So to remove this, remember this is more than one. So what you will now do is that you will put the names of columns that you want to remove. You will put it in a list under the dot drop attributes. So in that case, I will say COVID-19 data frame dot drop and I put the series of columns that I want to remove, okay, which are active cases and population. Remember, I will say axis is equal to columns. But one thing is that if you say columns or one, you are saying the same thing. But because people used to forget, is it one, is it zero? If you use zero, it means you are removing rows. But in order to be explicit, that is why it is good to say axis is equal to columns. So let me now replace one with that. I just say axis is equal to columns. Now that I have specified that, I can run it and you will note that the column active cases and column population variable has been removed in my data frame. Now I have the remaining series left without active cases and population. So this is also saying the same thing. It's either you say axis is equal to one or axis is equal to columns. But I will prefer you express it explicitly. Just say axis is equal to columns. Let's see another example where we'll be dropping two columns in our data frame. So let's copy the last example which we have here. So let's copy it. Okay, and let's create some cells. All right, this is what we have before. Okay, as you can see now. So let's save the resulting data frame as new COVID-19, for example. Let's say new COVID-19 and save the result as this. Okay, great. So if I run this now and I call the name of my new data frame, which is new COVID-19, I have this. So now I want to remove COVID-19 death cases and discharge rate from this data frame. To do that, I will do like this. New COVID-19 data frame dot drop, okay? And in that, I will put a list of columns that I want to remove. In this case, I want to remove COVID-19 death cases. So I type it there, COVID-19 death cases, COVID-19 COVID-19 death cases, COVID-19 death cases. I just say COVID-19 death cases, as you can see, COVID-19 death cases and discharge rate. I want to remove discharge rate as well. Discharge rate. Okay, so having specified that, I can move away from my list because I'm done with that. Then I will introduce axis. Because if you don't put axis there, see what happens. You will have an error. That is why you have to introduce how you want to remove that columns. So in that case, you say axis is equal to columns. All right. So if you run it now, you get an error, but let's see what the error is saying. Discharge, as you can see, they will misspell discharge rate. So we have to, redo it by correcting our error. So in that case, I just say discharge, D-I-S-C-H. Now it is correct now. Let's run it. You can see that we have now removed COVID-19 death cases and discharge rate from our data frame. People often replace the new data frame with existing data frame. They replace this one with existing data frame, which is this guy here. So in that case, you can just introduce another argument called in place. Remember, we have used in place before, right? You say in place is equal to true. So which means that it will replace the initial data frame with our new data frame, which we have death cases and discharge rate being removed. So now, if I run this now, as you can see, it works. So to see that my data frame, I can just call it, say, new COVID-19. And you now see your result, as you can see. In this video, you will learn how to filter your data frame. What is filter? You can filter your data frame by a particular condition. For example, let's say you have this data frame called registration data frame. Now, if I run it now, as you can see, you have just 3 columns and they are country, sex, and age. Let's say that you want to filter this data frame by male so that you can only see all the male students. In that case, we'll be using filter. So let's see how it works. Now, we want to filter by gender. So what we do is that you will select the gender column in your data frame by this. So now if I do like this, okay, I'm having error because remember in the previous video, we've replaced gender with sex. So now I can just replace this guy with sex. So I just say sex. Now as you can see, I now have my sex column. So now in this sex column, okay, we can use conditional statement, by saying that we want to see only the female students, so that when it is not going through that series, everyone that is female will receive true, otherwise it will be false. And that is what we are doing here in step 2. Remember, I have to change this guy to sex because I've replaced gender with sex colon before. So now I have done this now. As you can see, I now have true for female and false for male because I am filtering by this condition. So after you have done that in step 2, you will now put this step 2 in the main data frame so that you can only see female students in your data frame. So let's see. As you can see now, it's like I'm getting a column, okay, which will give me true. And those are the one for females. So if I do it in step 2 now, see what I have. I now have a new column which has only female students. One good thing we can also do is that you can actually do all these steps at once. and this is how it works. So let me show you. The first thing is that let's see your data frame. This is your data frame, as you can see. Okay, in that data frame, you will put a square bracket like you want to select a series. Okay, in that case, you will now redo this guy again. Say registration data frame, all right, registration data frame. From there, you are selecting just sex, okay, which is this. But now you are now looking at the condition whereby only the female that are in this data frame will be selected. So I just put female here. I will now see the main stuff. As you can see now, I have now filtered all the female students. As you can see, I only see all the female students in my data frame. Let's see, I want to see male student. So what I will do is that I will just replace female by male. So let me copy this guy. Let me open a new cell and copy, paste this guy. Okay, let me copy it again. You see now, let me paste it here and then replace this with male. Okay, now, as you can see, I now have only the male students. That is, data set for only male students. Let's see another example using COVID-19 data. So in this case, I have my conditions here. In my COVID-19 data, I want to select COVID-19 cases that is less than 300,000. I want to select COVID-19 cases that is less than 3,000. Okay, and from there, I want to get the number of rows that I have by filtering with this condition. Okay, I also want to see COVID-19 death cases that is less than 50 and also total recovered that is 200. Okay, then another example is I want to filter COVID-19 death cases that is less than 50 and total recover that is 200. Then I want to see how many data frame. Then I want to see how many rows I have by filtering with this condition. So let's do it one by one. The first one is to filter by COVID-19 cases that is less than 3,000. So let's see it. This is our COVID-19 data frame. Remember that we created this COVID-19 data frame by ourselves in the beginning. Okay? Now let's see how to do with example 1 by filtering COVID-19 cases that is less than 3,000. So what I will do here is this. Remember, let me delete this guy so that you can see how it works. The first thing to do is you look at your COVID-19 data frame, which is what we have done here. And after that, so you call the name of the variable like this, COVID-19 data frame, put a square bracket there, put a square bracket like this. Okay, call the data frame again by saying COVID-19 data frame. COVID-19 data frame. Okay, after you have done that, select a variable or a series that you want to filter with. In this case, I want to filter with COVID-19 cases, which is this guy here. So I just type it COVID-19 cases. All right, after I have done that, then my condition will now be that it should be less than 3,000. So in that case, I will just do like this, less than 3,000. Okay, and I'm done. So if I run it now, see what I have. I have this. And the question is now asking again that how many rows do we have left? Remember, you can use dot shape to see the number of rows that you have left. In this case, I have COVID-19, which is what I save my resulting data frame to. And I can say I can use dot shape. Remember dot shape. Okay. Now as you can see, this is giving us 2 rows and 8 columns, because if you count these columns here, they are 8. But the question is, how many rows do you have left? And that is 2. That is why the answer here is 2. I hope you now know how to filter your data frame by a condition. Let's see another example. In this example, we want to filter the same data frame by using this condition. Okay, the condition is that COVID-19 death cases must be less than 50 and total recovered must be less than 200. As you can see, COVID-19 death cases must be less than 50 and total recovered is less than 200. Okay, so let's see what we can do. Here you see that we are having two conditions at the same time. The first condition is that COVID-19 death cases must be less than 50, and the second condition is that total recovered is less than 200. So let's see how we can do that. Alright, so I will be using my data, which is COVID-19 data frame. So the first condition is what I put here. As you can see, COVID-19 death cases is less than 50, but because this one is having two conditions, I have to introduce the and symbol. And symbol will help us join the two conditions together. And the second condition is that total recovered cases must be less than 200, and that is what I have here. Remember, this is the column, but I have to attach my data frame with it. As you can see, the condition is 200. You will note that I have a parenthesis here in the beginning here and also close it at the end here. And that one helps us to solve the two conditions at the same time. So if I run this guy now I now have just one row. And to get the number of rows, as you know, you can use dot shape to do that. I can just say COVID-19 data frame solution 2 because that is what I saved my resulting data frame, and I call shape on it. And you can see I now have my result. So here I'm having 1/8, which means that I have just one row and then I have 8 columns. I hope you learn something now. Filter is used to filter our data frame by a given condition. Although the condition may be more than one, as we have seen in the second example, while in the first example, we only filter by one condition. And when you are filtering, you have to use some comparison operators. It may be less than, greater than, double equality, less than or equal to, greater than or equal to, depending on the situation at hand. Let's review what we have learned in this data frame. We have learned that a data frame represents a table which has number of rows and number of columns. You also see that a series will represent a column of your data frame. And to create a series, we are going to use pandas function, which is pd.series. And to also create a data frame, we are going to use pd.dataframe. But before that, we must have created a dictionary which will represent key and values. The key will represent the columns, while the key will represent the column, while the values will represent the observation in the rows. So let's see this as an example so that we revise what you have mastered. Here we have an example like creating a data frame, okay, for an Irish data, because this example is taken from the Irish data. And let's see how the data frame looks like. This is the data frame that we want to create. As you can see here, we have just 5 columns. And we have how many rows? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 rows. So let's see. So they are asking us to create this data frame and also get the number of rows and columns in this data frame. Then after that, we should rename series, we should rename species, as you can see here. they ask us to rename it to flower categories. Then we should add separate length and separate width together. Separate length, this one, and separate width, this one, they wanted us to add it together. And we call the result series as separate length width. You know how to do it, right? Okay, great, I'm happy. Then after that, they want us to drop the column petal width, this one here. They want us to drop it from the data frame. Remember, we have done that before using the dot drop attributes. Then after that, they want us to select the data frame where separate length is greater than 5.5 and name it perfect data. Wow, as you can see, all these are very easy. So let's see how to do that. The first thing to do if you are doing it from the new notebook is that you have to import your packages, and they include the NumPy and pandas. So let's run it. We have run it now. So now we need to create a data frame out of this data set. So let's see how to do that. Remember that the first thing is to create a dictionary where the key will represent your variable name and the values will represent the observation in each series. So let's see how to do that. We have separate length because separate length is the first column. Okay, we put it in a key and we put its value under a list. As you can see, here are its value and we now put it under a list. So we do it for every column like that. So let's say we have done that and run it. Okay, you can see that this is a dictionary. Okay, you may want to check it, but this is not important. So after you have created a dictionary, the next step to create a data frame is to pass your dictionary into pd.dataframe, and that is what we have here. As you can see, we pass our dictionary here into this pd.dataframe. Okay, and you run it. Okay, as you can see, we have saved the result into flower data frame. Okay, when you are creating a variable, you must follow the naming convention as you have done it in CS21, because if you don't do it very well, you will get an error. For example, if you just put, let's say, a space here and you run it, you get an error because this is not a valid variable name in Python. So I showed you that one so that you not forget how to name your data frame. Okay, let's say I've saved this. So to call what we have saved in the output, we can just call the name. Now we now have our data frame, which looks like what we have in this image. As you can see, it looks like what we have here. Okay, great. So having done that, the next thing to do is to get the number of rows and number of columns in our data frame. And we have the dot shape to help us get that. So let's see, you say flower underscore data frame, because that is the name of a data frame, and you call dot shape. Is this how to do it? Oh, let's run it first. When you run this, you get an error. Why? Because the dot shape attribute does not support parentheses. So we have to remove this parentheses and run it again. You now get the result. So now you can see that we have 8 rows and 5 columns in our data frame. All right, we are doing well. Let's continue. The third question is that how many series are in our data frame? Remember that a series represents a column in your data frame. So we need to count the number of columns that we have in our data frame to get this answer. Okay, so to do that, you may want to, you may want to do like this. You want to do like this, say flower data frame dot name, column names. You can just say columns. All right, and then you count it. Just say 1, 2, 3, 4, 5. Now you can see we now have 5 series in our data frame. The fourth question is to rename the species into flower categories. That is, we should rename our species series to flower categories. Do you still remember to do that? Oh, great. We are going to use the dot rename attribute, right? Great. And that is what we have here. So you use dot rename attribute, then you specify the columns, and you now put your key and the value in the dictionary like this. So the key will represent the old variable that you want to rename something to, which is series here, which is species here, and then the new name, which is the flower categories, and that is what we have here. So if I run this now, you will see that I now have the results. Okay, great. And remember, you can also say in place is equal to true, so that you can now have this as a new data frame, and you can call it again, say flower data frame. Now you can see the species variable name has been replaced with flower categories. Let's see the fifth question. The fifth question says that we should add sepal length and sepal width together and call the resulting series sepal length width. To do that, we have to create a new variable and call it sepal length width. And this is how to do it. So you call your data frame, put the new variable in a square bracket like this, and then the formula that will help us get this is what we will specify here. So in this case, I'm using dot operation. I've told you not to use dot. So therefore, let me just remove this guy. Okay, let's call our square bracket there. Okay, like this, just to select this variable. And remember, this is a string. We have to put it in string by putting quotation in it. So having done that, I will do the remaining one, which is my sepal width, because I have said you should not use the dot to get your variable. So here I have this now, as you can see, and put it in a quotation so that we can get the results. So if you have done that, you can run it. Now we now have a new variable called sepal length width, which added sepal length and sepal width together. So let's see the sixth question. The sixth question says that we should drop the petal width variable from our data frame. And remember, to do that, we have to use the dot drop attributes. So in this case, I will say flower data underscore df dot drop, and I put what I want to drop into this. Something is missing. I don't know if you can guess it already. If I run this, you see I have an error. The reason is that I have to specify which argument. Okay, great. Axis, yes. I will just say axis is equal to columns, and that is what I have here. Axis is equal to columns, so that it will know how to remove that variable. So if I run it now, I now have the result as this. Okay, so let's see the last question. The last question is saying that we should select a data frame where sepal length is greater than 5.5 and call it perfect data. So which means that we are filtering our data by this condition. Sepal length is greater than 5.5, and the resulting data frame, we should call it perfect data. So let's see how to do that. So what we do is to call your variable like this, which will hold the resulting data frame. In this case, I say perfect data is equal to, alright, since we want to filter this, so what we do now is this, because our variable, we have already called it flower data df drop. So that's what we are using now. flower data df drop, okay? And we now put our condition on how the data frame will be filtered. So in this case, I just say it again, flower data df drop. The condition is this, that is sepal length should be greater than 5.5, and that's what I have here. So if I run this now, I now have the results. See, we are seeing flower data df is not defined. Let's see what happened. So we have to run this guy, okay, and come back again and rerun this. Now we now have the result, as you can see. So now the resulting data frame, which is perfect data, is having 4 rows and 5 columns. We have now come to the end of this video. Thank you so much, and see you in the other video. Bye. You are welcome back. In this video, you will learn how to import datasets with pandas. Remember that in the previous videos, you created a data frame from scratch, but in the real world, already you have your own dataset, either in CSV or in an Excel spreadsheet. So what you will need to do is to import it using pandas. Before you can import your dataset, you must know the extension of that file. For example, for an Excel file, it must have this extension called .xlsx. For the CSV, which is also known as comma separated value, you must have this extension called .csv. While other formats are also available, such as SPSS data, which have .sav extension, we also have another extension for stata, which is called .dat. But majorly, analysts prefer either CSV file or an Excel file with .xlsx. So let's see how we can use pandas to import this. With pandas, remember that you must have imported your package. For example, import pandas as PD. Then, to import CSV, we will use the function .read_CSV. And for Excel file, which has .xlsx, you are going to use .read_excel. And for other file extension such as JSON, you will use read_JSON, and JSON is JavaScript object notation. It's another file extension. As I said before, analysts always have many file extensions, but majorly the most common one is CSV, which you are going to import with read_CSV, or Excel, which you are going to read with read_Excel. Let's go to the lab session where you see all of this in action. But before we go to the lab section, let's see our code snippet. Remember, you have been using this snippet since the beginning of this module. Now, I want to show you something. Open this file, because in this video, we will be importing different datasets. For example, in this class, you will use this folder called datasets. While in your various activities, you will be using activity dataset. As you can see, we have files here for the activity dataset. While in this class, I will be only using datasets which are in this folder, as you can see. One thing you will need to do is to first of all identify your file extension. As you can see, I have my file extension. When I go to this, I can see this is a CSV file. I can see this is an Excel file. But in your own case there, you may not see this, I don't know, depending on the setup of your computer. But let us resolve that. So to see your extension, you are going to click on View, then click on File Name Extensions. If you tick this, you'll be able to see all your file extensions. Imagine I remove this, see what happens. I will not be able to know the kind of file extension that all these are. But as you know, before I can import my file, I must know my extension, and that is why we are going to tick this. And this is just one time. Once you have done this, you don't need to come and do this again and again. Okay, so let's open our Jupyter Lab notebook where we see all this. I have launched my Jupyter Lab notebook. The file I will be working with is known as pandas2. So open your pandas2. As you can see, this is the pandas. Since I've already explained this on my presentation slide, I will not start from that. I will start from example 1. In example 1, you can see my file, which is already in Excel. As you can see, this is how Excel will open it. But if you look at this file, this is a CSV file. Excel can open both CSV file and Excel itself, which has .xlsx extension. Okay, so let's see how we can open our CSV file with pandas. Remember, the first thing to do is to import your packages. And my packages will be import numpy as np and import pandas as pd. So let me run this. Now, as you can see, I have imported my packages. What we need to do next is to use pd.read underscore. As you can see, since this is a CSV file, the pandas function that will help me to load this file will be pd.read underscore csv. Okay, so let me close this so that you can see how I type it. So I'm going to use pd. Remember, the variable that will save my output is Ethiopia flower because this is the Ethiopia flower dataset. And I call this name as Ethiopia flower. Then I will just type pd.read underscore csv, read underscore csv. Having done that, I will put a bracket there. You open a parenthesis and you close your parenthesis. Then after that, you will put double quotation. Okay, remember my file is in this dataset. It's in this folder called datasets. So if you double click on this, you'll be able to see Ethiopia flower, which is this one here. As you can see, you can also drag this to see it clearly. This is it, Ethiopia flower.csv. So now what I will do is that I will reference this folder in this place here. So you can just press tab on your keyboard. Okay, as you can see, when I press tab on my keyboard, all the files on this system appears. Okay, the lazy way of doing it is to scroll down and be looking for the data set. But as you can see, there are many options here. So what I will do is to locate this folder. Okay, let me come here. Locate this folder, that is data sets. So I just type data sets, as you can see, data sets, and I will put a backward slash. So after I put a backward slash in this double quotation, I can then press tab key on my keyboard, which will show all the data sets on my folder called datasets. From there, you can now scroll to the one that you want to import. In this case, I want to import Ethiopian flower.csv. So if I just press enter on my keyboard, I have everything done. Remember, the next thing for us to do is to run this script, to run this code. From there, you can just press Ctrl Enter. Now you have your data frame already being loaded for you with pandas. So the first thing to do is to first of all use the attribute edge on your data to see the first 6 observations in your data frame. Anytime that we are importing our data set with pandas, the output will always be a data frame. And by that, you can use all the attributes for data frame that you have learned in the previous videos, such as .ed, dot tail, dot columns, and all of that. So let's use dot head on this one to see how our data set look like. Okay, great. I will do like this, Ethiopian, because that is the output I saved it with, and I can just say dot head. Remember, with parentheses, and now I run it. As you can see now, I have my file. I can see the sepal length, the sepal width, the petal length, the petal width, and the species, as you can see. Then to check the kind of data structure that this one is, you may want to use type, as you can see, type, and to show you that this is a data frame. Okay, great. Now we have seen the head, and if you like, you can also put 10 inside that parenthesis to see the first 10 observations in your data frame. You may also want to see the last few observations in your data frame by using the tail function. If you specify 5 inside the tail, you only see the last 5 observations. And if you omit it, you will still see the last 5 observations, as you can see it here. And to see the number of rows and the number of columns in this data frame, you may want to use the dot shape attribute. As you can see here, the dot shape attribute gives us 350 rows and 5 columns because that is what we have in our data frame. Now let's see how the dot columns look like. The dot column looks like this, which gives us all the columns in our data frame. As you can see, here are they: sepal length, sepal width, petal length, petal width, and species. Okay, so we may also want to see the dot info, which gives us the data types of each series in our data frame. So let's use this. Now, as you can see, you see that sepal length is of float data type. That is, it has decimal places in its as its objects. We can also see that sepal width also has float as its own data type. Only species has object data type, which is also known as a string. Okay, great. Now that we have known how to import a CSV file, let's see how we can import an Excel file itself. It's just the same thing. The first thing to do is to identify the file extension. After that, use pandas to read that file, and that is it. So let's see this one. This one, we have East Africa names.xlsx. As you can see, here is a data frame of different names in East Africa. Okay, great. So to import that, you can just, and one other thing about Excel that I forgot to say at that time is that since Excel may contain different sheets, such as this, as you can see here, we have sheet 1, sheet 2, sheet 3. We therefore need to specify the sheet name that we want to import. As you can see here, where our data set is in sheet 1. Remember, Python index starts with 0. So this sheet will be called sheet name equal to 0. 0 means that we are opening only the first sheet. And if you put 1 here, it means that you need only the second sheet. You can see that this is very simple. Okay, so let's see how to do that. So we want to read the data set in this folder called East Africa Names, and this is it. East Africa Names.xlsx. As you know, this is an Excel file. So let's see how to do that. Let me delete this just to show you how we can encode it and import our data set. I'm going to call this data set East Africa Names. Then I can just say pd.read underscore. Okay, I may press tab to see various reads options. And from here, which one am I going to take? Excel, right. I'm going to take Excel because this file is an Excel file. So after that, I will put parentheses, and I'm going to put quotation in my parentheses. Now, the next thing to do is to identify where our data set is. If you look at this one here, you will see that our data set is in this folder. That is why I'm going to specify this folder, that is data set. Okay, so after that, I will put a backslash. In that case, I can now press tab on my keyboard. So if you press tab on your keyboard, you will see various data sets in that folder. Then you can now select the right data set. In this case, I'm going to select East Africa names .xlsx. So I press enter on my keyboard and I run it. As you can see, I forgot to put this argument, which is sheet, to identify the sheet position. If I forgot to do that, what Pandas will do is that it will select the first sheet for me. Okay, but to be in good standing, you may want to specify the sheet name, okay, and put 0 there. You still get the same result, only that this one is good in case you have many worksheets and you only want to load a particular worksheet in your Excel file. Okay, now that I have loaded it, let's see what is in that data frame. To see that, you may want to use .h on it. Let me remove 20 so that I see how it looks like. Now you can see various names such as Adan, Adam, Aden, Amina, and Abada. And you can see their gender. Some are male, while some are females. And you can also see the origin at which those names come. For example, Adan is from Somali, while Adam is from Urdu. As you can see, which means that a name can come from different origins. For example, you see Adam is from Urdu, is from Somali, is from Estonia, and so on. You can also see Abada is a male and also from the origin Arabic or Buharic or Saidic, as you can see. Now let's see how we can also import another file called JSON. I have told you what JSON is. JSON means JavaScript Object Notation. This JSON is commonly used when you are dealing with web data. And also in your field data management, they may ask you to open a JSON file. Okay, so in this example, we want to import JSON file. So let me close this guy so that I can see my screen clearly. Okay, so now let's see how to open JSON file. So there's a file called Uganda Women. It's a JSON file under our dataset. I've already shown you how to do that by putting a quotation and then put dataset slash the file name that you want to choose. Remember, this is a JSON file. In this case, we are going to use this pandas function called read_JSON, and then you run it. As you can see, it's very fast. Now I have Uganda women, and from there I can see what is inside Uganda women data frame. Now you can see the height of Uganda women and their weight, as you can see. And also to use the tail will give us the last 5 observations, which are for women in this case. I can also look at the shape to see the number of rows and the number of columns in this data frame. One thing is to import your data set with pandas. The other thing is to export your data out of Python or pandas. You can see we have seen various cases on how to import our data set with pandas. So let's see how we can export our data out of pandas. Okay, now to export your data frame, what you will do is that you will put the .to on your data frame. For example, if you want to import, for example, if you want to export your data frame as CSV, what you will do is that you will call this .to underscore CSV, and then you will put the file that will become your data set in Python. For example, let's say I want to save my data frame as a CSV file. So what I will do is that I will put the .to.df. So what I will do is that I will put the .to.csv into my data frame, and then the name I want to call my new file is what I will put inside this. The same thing also applicable to other files such as Excel and JSON. So after I have my data frame in pandas, so to export it out, I will just say .to.cs, I will just say .to.excel and put the name that I want to call my file in that double quotation. So let's see an example. In this case, I want to first of all import a data called fatal police shooting data. It's a CSV file. Okay, after I import it, I will call it as police shooting. Then after that, I will now show you how you can export that data frame as stata file or Excel file or JSON file. So let's see it. This dataset called fatal police shooting is in my dataset folder. So what I will do is that I will just say, remember the first thing, let's say this is a new script. The first thing to do is to import the package. That will say import pandas as PD. After that, then I can call my new data frame as this, police shooting. Then you call the name, that is pd.read underscore csv, because here you want to import that data set. Then after that, you call the file name. In this case, we have fatal police shooting data.csv. Then let's run it. As you can see, we have imported it successfully. Then after that, let me see the first 5 observations in my data set. I can just do like this. As you can see now, I now have it like this. I can see the date, I can see the manner of death, I can see armed, is it gun down, is it unarmed, is it toy weapon, is it nail gun, and all of that. And you can see those people that were affected by police shooting. This is an interesting data set. Okay, you may want to see the shape of this data, that is to see the number of rows and the number of columns in this data frame. Remember, to do that, we are going to use the shape attribute. Now you can see we have 5,793 rows and 4 columns. And you also want to examine your data frame further by looking at different objects in your series. So let's see. As you can see, date is an object data type and all of that. So now our business now is to export this data frame out. And to do that, we have to call the .to our data frame. For example, if I want to take it as a stata file, I will just say to underscore stata and specify the directory that I want to export it to. Then I will specify the directory that I want to export it to. So in this case, I'm still putting it under this file. As you can see, I'm still putting it under this. As you can see, I'm still putting it under this file called snippet code. Okay, then here I want to select dataset. As you can see here, this is where I want to export my data frame to. That is why I said dataset slash then the name that I want to call this file. So in this case, since it is a stata file, the extension of stata file is .dta. That is why I included .dta here. So if I run it now, Okay, as you can see, it has now exported it out. So to confirm whether it is true, you can just come to this guy here and then look for the file name, which is policeshooting.dta. Police shooting, as you can see, here is now my file. Okay, I understand that data file is not that common, but let's see how we can export a data frame as an Excel file. In this case, I will call my data frame, which is the data set that I have imported with pandas. Okay, so to export this out, I will just call dot to Excel. As you can see, dot to underscore Excel. Then inside it, I will now put the directory at which I want to export my data set to. So in this case, I will say data set slash, as you can see, slash. So we are using backward slash, slash. Then the name of your new file. So in this case, I call it police shooting. And the extension of that file will be Excel, which is .xlsx. Then after you have done that, you run it. As you can see, it's running. Now it's done. So you may want to look for it. This is it. Police shooting.xlsx. So let's see how we can export a data frame as a JSON file. The same thing applies. So what we do is that you first of all call the name of the data frame, which is this guy. And then the function that will help you export that data frame is to underscore JSON followed by the directory of that file in which the file will save into. So in this case, I will be having dataset slash police shooting. Then don't forget the extension of that file that you are exporting to. If you forget to add the extension of the file, then your program will not be able to open such a file. So I don't want to forget what I am doing. I'm going to add the JSON file to it. Okay, great. And now run it. You can now see this file here, which is police underscore shooting.json file. And I also screenshotted it for you here so that you can see how the dataset looks like. Let me give you one bonus. Remember, I've not done CSV for you. I only did the data, which is the .dta, and the Excel, which is the .xlsx. And also I did JSON for you, which is the .json. So let me do the CSV file for you so that you can see that this thing is very easy. It's very, very, very easy. It's just like shawarma, very sweet, right? Great, let's do it. Now I want to open a new cell. In this case, I'm going to call my data frame, which is the police shooting. Okay, I say police shooting. That is my data frame. You may want to see. As you can see, it's my data frame. So to export this data frame, we are going to say to dot to underscore, which will now comprise the extension of the file you want to export to. So in this case, I will just say to CSV. All right. So if I do this, then I will now put parentheses there. Inside that parentheses, I will put quotation on it. Then I can now call it a name for that file. So here now, I can just say police shooting, for example, police shooting. The name I will call my file depends on me. Okay, so it also depends on you when you are now practicing it on your own. It depends on you. You may want to put a name for your file. So in this case, I chose to do it in this way, police shooting. Then as I told you, don't forget the extension. The extension will be to CSV. If you look at what I'm doing here now, you can see that I did not reference this data here, which means that the file here will be saved around this level. It will not go to my data set. It will only go to this parent folder. So let me run it for you. As you can see, it works now, and I can see my data set. Let me see. Police shooting. All right. Now, as you can see now, this is the file, police shooting. But imagine I also specify data set. So if I say data set, okay, slash, then if I run it, it will work. Then in that case, it will go to this guy here, which is what I have here. As you can see, police shooting the CSV. I believe that this video has taught you how to import various datasets with pandas. We've learned how to import a CSV file by using pd.read_csv. We also saw how to read an Excel file by using pd.read_excel. And you also saw how to read a JSON file by using pd.read_json. You also saw how to export a data frame out of pandas. In that case, from your data frame, you just say dot to underscore and you specify the extension that you want to export to. Thank you so much for watching this video. See you in the other video. Bye. Welcome back. In this video, you will understand data cleaning. Data cleaning is also known as data pre-processing. One of the concepts in data cleaning is missing value. What is a missing value? A missing value is that there is a data point that is missing in your data set, and Python identify a missing value by using NA, NaN, or null. And to check a missing value, pandas has many functions such as is NA or is null. You may also want to identify the number of missing values in your data set, and we have these functions to help you do that. And the function is NA dot sum, which will give you the number of missing values in each of your variables in the data set. So let's see all of this in action. So I'm going to open a JupyterLab notebook called Pandas 3. Remember that you have to go to your snippet codes for CS22 and then open Pandas 3 to follow along with me. In order to see this video clearly, I'm going to close this so that you can see everything at a glance. I'm going to import a dataset called Somalia Women CSV. So before I import that dataset, I have to import different packages that will allow me to work with this dataset. So one of the package is NumPy. Remember, we have to import NumPy by using import NumPy as np. And for data importing and all of that, we also need to use pandas package. Remember, to import pandas package, you have to write import pandas as pd. So let me run all this. As you can see, it's running. The code cell is running, as you can see. Now, our packages are now ready because they've been fully loaded. I also need to import my data set, which is Somalia women. The data set contains the height and weight of Somalia women. So let me import it. So this data set is at the data set folder. As you can see, if I go here, if I look at data folder, you will see Somalia women CSV there. This is it. As you can see, Somalia women. And I'm going to use pd.read_csv to import that. So let me run my code cell. Now my code cell is run. So let's see the first 5 observations in this data set. So in that case, I will be using the .head function to do that. As you can see now, I can see NaN here, which is a sign that there is a missing value in this data frame. It is not always that missing value will be at the starting point. No, you only see the missing value here because our data frame contains a missing value. But let's see whether truly there are many missing values in this data frame. So we are going to use is.na for our data frame in order to see whether there is a missing value or not. So I'm going to use is NA attribute to see whether there is a missing value or not. So I do like this, is NA. As you can see, I have series of true or false. As you can see, true, false, 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 and all of that. So the false represent there is no missing value, while the true represent there is a missing value. There are also another attribute that can help us see whether there is a missing value or not, and that is null. It means that you have two attributes that do the same thing. So it's either you use is any or is none. So now let's see how many missing values are in each of the variables. So in that case, I have to use dot sum attribute in order to see the number of missing values in my data frame. So let's see it. Remember, you have to put your data frame here, which is the Somalia woman. As you can see, Somalia woman. Then you use dot is NA. Don't forget to include the parentheses, otherwise you may get an error. So after that, because this one will give you series of true or false. So after you have done this, then you will now put the dot sum attribute. As you can see, dot sum. Then you close the parentheses. And if you run this, now you will now see the number of missing values in each of the variables. You can see that the height variable or height series has 4 missing values, while the weight series or the weight variable has 5 missing values. Is that interesting? So let's see another data frame. In this case, I will be importing police shooting dataset. Remember, my dataset is at the dataset folder. That is why I am including it here. And one thing about this dataset is that it's an Excel file. And you know, to import an Excel workbook, you have to use pandas function called pd.read_excel. And that is exactly what I do here. So I'm going to run this. As you can see, it's loading. Now it's completed. Remember, to see whether there is a missing value or not, I can use is NA, and is NA will only return series of true or false for my data frame. But in order to see the precise missing values, I can now use dot sum against that, so that it can give me the number of missing values in each of my variables. And that's exactly what I do here. Now you can see that we have missing value for armed, we have missing value for age, we have missing value for gender, we have missing value for race, we have missing values for longitude and latitude. While the zero indicates there is no missing value. As you can see, what you need to master is just all this. It's NA dot sum, and that's all. You now get your result. Welcome back. In this video, you will learn data imputation. What is data imputation? Data imputation is a process at which you treat your missing value. And you have two ways at which you can treat your missing values. So the first one is to get rid of them, either by row or by column. For example, let's say in the Somalia woman data frame, as you know, we have two columns, which are the height and the weight of Somalia women. Let's say there are missing values at the height column. So the first method here says that you should remove that. And that's exactly what the get rid method will do. The get rid method will remove the missing values either by rows or by columns. Another good way at which you can treat your missing value is what is known as data imputation, and that is the process at which you replace your missing value by a known value. A known value could be replacing it by the higher value, which is the maximum value, or replacing it by the average value, which is the average of all the values that are present and that are known in the variable. So let's see them one by one. The first method to treat is getting rid of a row or column that has a missing value. I will be using Somalia women to show that. In the Somalia women, as you can see, we have the height and the weight of Somalia women. And before I get rid of any missing values, let's see the number of dimensions in this data frame. Remember, to get the number of dimension, you will use the dot shape attribute. So in this case, I run this. As you can see, we have 250 rows and 2 columns. And to see the number of missing values, we are going to use this attribute, which is NA and dot sum all together. As you can see. Now, as you can see, we have 4 missing values at the height column and the 5 missing values at the weight column. In order to get rid of any missing values by row, we can use the attribute called drop NA from pandas to do that for us. So let me do it. As you can see, this is how to do it. You will just put this attribute against the data frame. And I'm saving the result as this, which is Somalia woman drop NA. So if I run this now, every missing value in this data frame will be removed automatically. So now let's check the remaining dimension after we have removed those missing values. Now let me run it. As you can see, now we are now left with 241 rows with just 2 columns. So if you look at or you consider the previous dimension, we have 250 rows and 2 columns. And after we have removed some missing values in that data frame, we are now left with 241 rows. Sometimes you may want to remove the column that has a missing value, and we will see it in action now. So I am using the East Africa names dataset in order to show you how to work with that. So look at your datasets folder and specify the East Africa names so that you read it. There's a problem in that dataset, and the problem is known as encoding problem. That is why we are specifying this in order to be able to import it successfully. So I run this. Okay. Now let's see the head of this data frame. The head of the data frame is this. As you can see, it contains names of people in East Africa. And some of them, as you can see, Adan, Adam, Aden, Amina, and Abada. You can also see their gender. For example, Adan is a male, while Amina is a female. So one other good thing about this dataset is that it also contains the origin where they have derived those names. For example, Adan is from Somali. And as you can see in this one here, so other origins are not available because they are missing. So which means that this Adan is solely from Somali. You can also see another name called Adam. It's also a male, and you can see that the name is from Urdu or Somali or Estonian, and that is how every name is being represented in this data frame. Now let's see the number of missing values in the data frame. Remember, to get the number of missing value, you have to use is NA with some attributes. So let's run it together. You can see that we have 970 missing values in the origin 2. We also have 1093 missing values in origin 3, while we have 1116 missing values at the origin 4. So let's see how we can drop columns that have missing value in this data frame. We are going to use the drop NA pandas attribute to do that. So one thing we need to note is that we are going to specify the axis at which we want to remove. Remember, in the previous examples, we don't specify axis. In that case, only the rows that has missing values will be removed. And when we are specifying the axis column, then it means that only the column that has missing values will be removed. Now let me do it. Before I do that, let's see the initial dimension of this data frame. So I will be using the dot shape attribute to get that dimension. Now you can see that we have 1128 rows and 6 columns in this data frame. Now let me call the drop NA by specifying the axis equal to columns to specify that remove any column that has missing value in this data frame. So I'm going to run this, and while doing that, I'm saving the new data frame as East Africa drop NA. So let me run it. Now you can see that I now have just 3 columns, which are the name, the gender, and the origin at which those names are being derived from. So if I call the dot shape again to see the new dimension that I have, you will see that I will only have 1128 rows and 3 columns, in which you can see already. As I said previously, that we have what is called data imputation. And data imputation is the process at which you replace any missing value by a known value. And the known value could be a mean or the median of the whole variable or the maximum or the minimum of the variable. So let's see how we can imputate any missing value in our data frame. I will be using Somalia women in this example. So let me see the overview of it. As you can see, this is the Somalia woman head data frame, and you can also see the number of missing values. And before I inputted that, so let's see the average height of Somalia women. In that case, I will be calling the column height from the data frame, and then I will be using the dot mean attribute to get the average height of Somalia women. So let me run it. As you can see the result here, the average height of Somalia women is 64.7. And this is the average that we will use to imputate our missing value in the height column. I'm also getting the average weight of Somalia women by using the weight column. As you can see, remember in the previous video, I've shown you how you can extract a column from the main data frame, and that is exactly what I did here. And I now call the dot mean attribute in order to get the average weight of that column, and that is what I have here. So if I run it now, you can see that the average weight of Somalia women is 64 lbs or pounds. Another way at which you can get the mean of every column in our data frame is by calling the main attribute against the main data frame, and that is what we have here. So if you do this, you will see that you are getting the mean of every column. For example, the mean of height is 64.7, while the mean of weight is 64.1. And this is different from this because this method is only calling the column height from the data frame, and in that we are now getting the individual mean of this height. The same thing with this, we are calling the weight column from the Somalia data frame, and we are getting the average weight of that data frame. As you can see, this is it. While this method will only give us individual column mean, and that is what we have here. And this method is actually better than the other, and you will see it when we continue. In order to imputate any missing value, we are going to call the fill any attribute. The fill any attributes from pandas enables us to imputate our missing value, by using a known value. And you have seen here that we've already seen our known value. For example, for height, we are having 64.7. So if you use the mean, it means that every missing value in the height column will be replaced by 64.7, while every missing value in the weight column will be replaced by 64.1. And let's see how to do that. So I'm going to call the resulting data frame by Somalia women input, as you can see, and I'm using the original data frame, which is Somalia women, and I'm calling the fill any attribute, which will help me to really imputate any missing value by using the average, average height or average weight for that column. And that is exactly what I did here. So if I run this now, as you can see, every missing value has been replaced now. So it means that any missing value in the height will be replaced with the mean height, while every missing value in the weight column will be replaced with mean weight. And that is exactly what we have here. So now, if we now call is na.sum in the resulting data frame, you will see that there will never be any na again. Now you can see for height we are having 0 na, and for the weight we are having 0 na. Welcome back. In this video, you will learn another process at which you can clean your data. In this case, you will be identifying whether there are duplicates in your data frame or not. So let's see how to do that. The first thing to do when you are doing a new data science project is to import your packages. And in this case, I will be importing NumPy and Pandas all together. Now that my packages have been loaded, I want to import another data set called course attendance. This is a data set that contains the name, the gender, the age, the country, the course taken. And let's see how to do that. Remember that our data set is a dataset folder. And so when you are importing it, please don't forget to include dataset in the part of your file. So let me run it. I'm saving the result as course attendance. And to see what is saved in this, I can just call this. Now you can see the whole data set at a glance. So let's see how to identify whether there is a duplicate in our data set. What is duplication? Duplication is a process at which an item appears more than once. For example, you can see that we have different gender, which are male, female, and so on and so forth like that. And also for the country, as you can see, we have Somalia, Kenya, Somalia, Sudan. You can see that there are some duplicates in country, which is normal. But let's say that you want to identify whether a particular observation appears more than once in your data frame. That is where you can now start taking care of those duplicates. So let's see whether we have duplicates in our data frame that we just imported. So let's see. To do that, we are going to use an attribute called duplicated. Duplicated here will give us just two values, true or false. True means there is a duplicate in that observation, and false means there is no duplicate. As you can see now, if I run this, now I have all this. Okay, so let's see another step, because it actually has two steps, and I'm showing you the first one, which is the dot duplicated attribute. The second step is that you will now include the dot sum attribute so that you can see the number of duplicates in your data frame. And in this case, I'm adding the dot sum attribute against the duplicated attribute. And now if I run it now, you can see it's telling me that there are 3 duplicates in my data frame. One good thing that you may want to look at is to identify where those duplicates are and what are the observations that are duplicated. And to do that, we will do it in this way. The first thing to do is to first of all call your data frame. And in this case, I'm having course attendance. Remember, we have this, okay, which gives us the number of duplicates in our data frame. So if I put this against this square bracket, it will then return those observations that are duplicated in my data frame. Now if I run it now, let's see. As you can see, I now have those observations. To be precise, what I need to do, I'm not going to include some. I will only include course attendance duplicated, which we have done here in the step 1. And remember, that one gives us the series of true or false. As you know, false means there is no duplication, while true means there is a duplication. So now, if I just do it as I do it here, okay, I run it now, I now have those values that are duplicated in my data frame. As you can see, it's interesting, right? It's actually very simple. You have just 2 ways or 2 steps. The first step is you call your data frame, and in that your data frame, you now put a square bracket, which is this, and in that you now put the data frame with the dot duplicated attribute, and that one will now return those duplications that are in your data frame. Let's see another example. This example is like what we have done before. Remember, in the first example, we want to know whether there is a duplicate or not. And I said we have 2 ways to do that. So the first step to take is to use the duplicated attribute, which returns the series of true and false. And in the step 2, we now use a square bracket inside it, as you can see, to really identify those duplications. And one good thing we can do is that we can actually do it with one line of code, and that is what we are doing in the second example. I hope you now understand it better. So which means that you don't need to start, looking at the true or false. Instead, you can just use one line of code. And this is it. You call out the data frame and you put a square bracket. You call out data frame again and you put the dot duplicated attribute against that your data frame, and you will now have the result as it is here. Another example is that you may want to select duplicate rows based on a particular column. For example, I want to identify those duplication by name. For example, as you know, in my data frame, I have many names, and I want to know the name that appear more than once. And that's exactly what I'm doing here. As you can see, I call out my data frame, I put a square bracket, I call out my data frame again, and in this, I call out the duplicated attributes. Because the duplicated attribute has one argument, and that argument, if you don't specify it, in that case, it will only show you observations that are duplicated. But if you specify something in that argument, then duplication will be treated by that column that you specify. So in this case, I specify the column name inside it, which means that it will only identify any duplication by the column name, and that is what I have here. So this one is showing us that Francisca repeated in our data frame. You can also see that Francis also repeated more than once in our data frame, while Simon too repeated more than once in our data frame. Let's see another example where we will see a duplication that appear in the course taking. Remember, course taking is another column in our data frame. So I just repeated my code and I changed the name to course taking. Now I can see those course taking that appear more than once. For example, CS13, CS22 that we are doing now, CS15, CS12, CS16, and so on. Okay, let's see the last example where we want to identify duplication by more than one column. So in this case, I want to see duplication that appear by name and by country. Now, as you can see, just the same thing. You call out your data frame followed by a square bracket, and inside that square bracket, you call out your data frame again, and you also put an attribute called duplicated. Alright, and inside that duplicated, you will now introduce a series, as you can see here. And inside that duplicated argument, you will now introduce a list. As you can see, inside that list, we now specify the name and the country. So what we are doing here is that we want to identify duplication by name and by country. Now you can see here that Francisca appear, and Francisca is also from Uganda. So which means that the observation that has Francisca from Uganda appear more than once. We also have another one here, which is Francis, and that one is also from Kenya, as you can see. So here now, we are now comparing that, okay, Francis from Kenya appear more than once, and also Francisca coming from Uganda also come more than once in our data frame. You can also see the last one here, which is Simon. Simon is from South Sudan, and that one also appear more than once. What does that mean? It means that maybe Francisca from Uganda, are taking more than a course. That is why it appear, because if you take more than a course, of course it will appear by name and by country as well. I hope you have now mastered how to identify whether there is a duplication in your data frame. Remember, we have the dot duplicated to help us do everything. You are welcome back. In this video, you will learn something new, and it is data exploration or exploratory data analysis. Exploratory data analysis, also known as EDA, is an approach by data scientists to analyze and investigate data sets by summarizing their main characteristics by using various data visualization methods. In a simple form, the main idea of EDA is to help look at data and see what it can tell us before making any assumption. EDA also helps us to identify any obvious error, as well as understand the pattern in your datasets. EDA also allows us to detect outliers and find interesting relationships among different variables. In this video, we will see how to use pandas to explore our datasets. But before we start that, let's see what pandas profiling has to offer us. What is pandas profiling? Pandas profiling is a Python module that extends the Panda data frame. So which means that majority of the work that we'll be doing here we'll be using another module called pandas profiling. So to use pandas profiling, you have to install it first. Now let me show you how to install pandas profiling. To install pandas profiling, you have to use this code, which is pip install pandas profiling. Please look at it carefully. Pip install pandas. You can see that there is an hyphen here. So there is an hyphen between pandas and profiling. Or you may want to launch your Jupyter Lab notebook by coming to pandas 5 so that you can easily copy and paste. So just copy this guy. Okay, then to actually install it, you have to open your Anaconda prompt. As you know, I have already launched my Jupyter Lab notebook, and that is why I won't be able to use my Anaconda prompt again. But there is another way to do that. In order to do that, you will click on File, then you click New, and then you select Terminal. As you can see, you now have a terminal. So in that case, you then paste your code, which is pip install pandas profiling. Whenever you are installing a module, make sure that you have your internet connection available, or make sure that your computer is connected to the internet.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love.
Now, as you can see, everything is now installed on my computer. Okay, you may also want to try it. Okay, what you just need to do is to put this code there, which is pip install pandas profiling. Now I have it. So I can go back to my pandas notebook, which is pandas 5. Now that I have installed pandas profiling, so let's see how to load it. To load pandas profiling, we'll be using from pandas profiling import profile report. This is it. From pandas profiling, import profile report, and that's exactly what we want to do. So I'm also adding other packages which are numpy and panda. So I'm running these guys all together. Okay, as you can see, it's loading. It's loading. Sometimes it takes some minutes or some seconds to fully loaded. I'm going to fast track this video. Now it is finally loaded. So to use this pandas profiling, I will use an example called Ethiopia flowers dataset. So let's load it. So we are using pd.read_csv to load this Ethiopian flowers dataset. So I click on it, as you can see, now it runs. In order to use pandas profiling, okay, I will be using an attribute called profile_report, and this is what will now do all the data exploratory analysis for me automatically. So let me do it. Remember, my own data frame is called Ethiopian flower, and that is it here. Then I am calling profile report on it, as you can see. Don't forget to include your parentheses. So if I run this now, let's see what will happen. As you can see, it's loading for me. It's loading, and then you now see several data visualization that will appear, histogram, bar chart, scatter diagram, and it will do it automatically for all the variables in our data set. As you can see now, it's very good. You can see it's telling us the overview of our data set in terms of the dataset statistics. As you can see, it's telling us the number of variables, the number of observations, if there is any missing values. As you can see here, there is no missing cell. It's also telling us if there is any duplication in our data frame. As you can see now, if you look at the previous video, you know that we are using a code to get whether there is a missing value or not. And here now, pandas profiling is doing everything automatically for us by just using dot profile report. You can see it's telling us the number of memory that we have used. Okay, and you can also scroll down to see those variables that it has done data visualization for. As you can see, this is the stepper length. You can see the histogram. You can see those statistics in form of minimum, maximum. You can see if there is any missing value in this variable. You can also go down. You can see stepper width, the histogram, and all of that. So interesting. As you can see, petal length, you can see all of that. You can also play with all this by clicking on toggle detail to see it, in terms of statistics, histogram, common values, extreme value, all of that being automatically done for you. You can see petal width, you can see species, and if there is a categorical variable, it will only draw a bar chart. If there is any continuous variable, then it will plot histogram for you. As you can see it here, and it's also showing you some interaction. As you can see, this is a scatter plot or scatter diagram to show whether there is a relationship between the variables. You can also see for the separ width and all of that. So interesting. And also, it's showing you the correlation coefficient in terms of Pearson correlation. Don't worry, you will see all of this in details in CS31. Now, this is the heat map to show the correlation among several variables. And for missing values, it's also showing you here if there's a missing value and all of that. It's also showing you the first 9 observations in your data frame and also the last 9 observations in your data frame. Remember, to do this by yourself, you can use dot tail, and for the first observation, you can use dot head. And this is exactly what pandas profiling is doing for you automatically. As you can see, so which means that this pandas profiling is actually very good. It's a good toolkit that you may want to add into your toolkit. Let's see another example where we'll be applying pandas profiling. So in this case, I'm importing a data set called money transfer transaction. And you can see this data set at the datasets folder. So let me import it. I'm importing it and I'm saving the result as money transfer. As you can see, it's loaded, and after the data frame is already set up, then I can call this profile report. It's an attribute, profile underscore report. Then you close the parentheses and you run it. And it now generate a lot of statistics, a lot of data visualization for you. And this makes it so interesting. It's a good toolkit that you must add into your tool. I'm telling you. As you can see now, you can see the overview of the data frame in terms of number of variables, just like what you have done before. You can see different visualization in terms of what variables are existing on your data frame. As you can see here, gender. You can see that in this data frame we have 297 females and 203 males. You can see the distribution of the age. You can see the direction, whether it's an inflow or outflow. This pandas profiling is so good. It's so fantastic. And I believe you are also enjoying it as I'm enjoying it here, because I'm so excited to know how to use pandas profiling. As you can see, it's also showing us different correlation in terms of the heat map and all of that. So that is exactly what pandas profiling does for our data frame. Welcome back. In the previous video, you've seen how to use pandas profiling to create different exploratory data analysis of your data. In this video, you will see how you can summarize your data. Precisely, we'll be using the .describe attribute to get the descriptive statistics of our data. So let's begin it. I'm going to import a data set called Somalia women. So let's import it again. Now that I have imported Somalia women data frame, let's see how to use that .describe attribute. So what you will do is you will call the dot describe attribute on your data frame dot describe attribute. Okay, and this is what you have. And what does it do? The dot describe attribute gives you the summary statistics of your data set. Now you can see that you have two continuous variables in your data frame and they include height and weight. Now you can see all the description here, the count, the mean, the standard deviation, the minimum, the 25 percentile, the 50 percentile, the 75 percentile and the maximum. That is exactly what dot describe attribute does. Let's see another data frame. In this case, I will be importing a dataset called East Africa Names dataset. Remember that this dataset is having an encoding problem. And to solve that, we are using encoding argument of the pandas read underscore CSV. So let's run it. Now we have the answer. You can see that our data frame here does not have any continuous variables. Everything there are just categorical variables. For example, the name, the gender, the origin, and all of that. So if you call the dot describe attribute on this data frame, we will not see what we saw in the last example where we are seeing all the summary statistics like count, mean, and all of that. So let me show you how this one will look as. So if I run this now, you can see I only have the count, the unique, and the top and the frequency. What does that mean? That means that we have just 1,128 names. And we also have 1,128 gender, and you can see for other variables. So the unique here is just talking about the uniqueness, that is, there is no duplication. So for example, now we have 1,047 unique names. You also have, as you know, gender is just male and female, and that is why we have two here. And we also have the top. The top means the most highest frequency, that is a particular value that appears most. So for example here, under the name, we have Ambessa, which appears most among different names that are present in this data frame. And you can also see the frequency and all of that. So let's import another data set. So here we are creating this data frame from scratch. Remember, in the first video of this module, you've seen how you can create your own data frame from scratch. So the first thing is to first create a dictionary, and dictionary will contain key and the values. You can see now we have key, which will later become the column of your data frame. So we have key gender, we have key country, and we also have another key called age. And now I'm also calling pd.data_frame to create a data frame from this dictionary. So let me run it. Now that I have run it, you can see how the data frame looks like, as you can see it here. Now, what I want to do here is that I want to extract the gender column from the data frame, and I want to call the dot describe to show you what we have seen in the previous example here. You can see that when I call the dot describe, I call it on the data frame. But here now, I am calling the dot describe on just the column, and that is why I'm having this. And if I have done it directly like this, I will have something like this. So let me say registration data frame dot describe and see what will happen. You can see what happens here is that it only does it for the continuous variable in that data frame, and because there's no way you can do it for both continuous variable and categorical variable, that is why this guy had to do it only for the categorical variable. Okay, although there's a way at which you can also specify it to do it for only the categorical variable. but this video will not show you that. Let's see how we can see the frequency distribution of a particular variable in our data frame. In that case, we will be using an attribute called value count. Value count will give us the frequency distribution of that variable. So in this case, I am calling gender column from a data frame, and I'm now using the dot value counts. Remember, it's value counts and not value count, because if you use value count, you will get an error. So if I call it now, you can see what I have. Now I have the frequency distribution. For example, I have females that are just 6 and men are only 4 in this data frame. Let's see another example. In this example, I will be using the East Africa names data frame. We've already imported it, so the data frame name is called East Africa. All right. And in this case, I want to call the value count on the gender column. Remember, I have called the gender column here, and I specify the attribute value count. If I run it now, as you can see, here now I'm having 614 males and 514 females. That is exactly what the value count does for us. What it does is to give us the frequency distribution of that variable. And sometimes, let's say that you want to get the percentage distribution. In that case, you will be using what is called normalize. So you specify normalize to be true in the value count argument. So let me do it one by one. So in this case, I'm going to create a new cell and say East Africa dot, remember I can say dot gender, but don't let me use dot gender because I have told you not to use dot gender. So in this case, I will just do like this. I just call gender, okay, and then I say value counts, value counts, value underscore counts, okay, and then you can just say normalize. Normalize is equal to true, and this will give you the percentage. Normalize is equal to true. If I run this now, see what I get. I now get the percentage distribution. Now you may be asking, this is not like percentage. Of course, you can also multiply it by 100. If I multiply it by 100, I now have this. You can see that males contain 54.4%, while female contain 45.56%. And at times, you may want to sort your result in either ascending or descending order. That is why we have this argument called sort. So if I just delete this guy, it will sort it, in descending order. As you can see now, 614 for males, 514 for females. And if I want to sort it by the percentage, then I'm going to include normalize equal to true in my argument. Okay? So if I run this, and now I'm getting an error because I misspelled the normalize. So now I cannot say normalize equal to true. Now I get it. All right. So we've already done this one before. This is where we are calling the gender column, and we are getting the percentage distribution of the gender. And now you can see that we have 54 are males, 54% of males, and 45 percent of females. I hope that you have mastered how to get the descriptive statistics of your data frame. And in this video, we've seen how we can use the dot describe attribute and the value count attributes. Thank you so much for watching this video. See you in the other video. Bye. Welcome to another section where you will learn everything about data visualization. Before we move to various techniques that are used to visualize data, let's see what data visualization is. Data visualization refers to the graphical representation of data by using visual elements. The element may be a chart or infographics, and sometimes you may also want to visualize your data by using maps. There's a story behind every data, and data visualization brings this into life. It enables decision makers to see the data analytics presented visually so that they can understand the difficult concept and see the hidden pattern. According to the English adage, a picture is worth a thousand words because our eyes are easily drawn to color and pattern. Data visualization helps us to grab the reader's interest and keep their eyes on the important message of the data. Why do we need to visualize our data? There are many reasons why we may want to visualize our data. Number one is that it's a powerful way to explore our data, and that is what is called exploratory data analysis. It displays the summary of our data at a glance. We can easily see the summary of our data when we visualize data sets. We can also use charts and graphs which make it easier to identify patterns and trends. Another reason why we may want to visualize our data is that it identifies areas that need attention or improvement. One thing is that people don't really understand what we are presenting by using table, except we visualize it. As we said it before, that a picture is more than 1,000 words. Before you visualize your data, there are important 5 questions that you must ask yourself. You must ask yourself whether you want to see the relationship between two or more variables, or do you want to understand the distribution of the data set, or looking for any outliers. Outliers are extreme value. It may be a value above other values or a value below other values. Sometimes they call it unusual data point. The third question to ask yourself when you are visualizing data is that, am I looking to compare multiple values or looking to analyze a single value over a time? That is where you can now see whether you want to use a line chart to show how the pattern is going over a time. And that is what is called a trend. The fourth question that you may want to ask yourself when you are visualizing data is that, am I interested in analyzing trend in my data set? Why the last but not the least is that, is this visualization an important part of my data story? Because sometimes maybe a single value can easily present the data point. That is why this question is now coming into life, whether you want to use that kind of visualization as part of your storytelling. One of the data visualization techniques that you can use to present your data is a bar chart. A bar chart is one of the simple techniques that one can use to visualize any categorical data. For example, here now we have a categorical variable called species, and in that species we have 3 levels which are Adelie, Gentoo and Chinstrap. As you can see here, the bar represents how many times such species appear in your data set. Now you can see that Adelie appear around 145 times, while Gentoo appear around 120 times, while Chinstrap also appear around 60 times. One thing about a bar chart is that it has what is called visual dimensions, and the visual dimensions in bar chart are these: the length or the count, which represent the frequency of the variable. We also have the category, which will be in the x-axis. The color is the one that identify each of the species in your data set. Don't let me forget that this one here is what is called y-axis, and that also represents the number of times that those species appear in the data set. Another visuals that we can use to visualize our data set is what is known as histogram. A histogram is always used to visualize any continuous variable. For example, this is a histogram. The difference between a histogram and a bar chart is that in histogram, there is no space among the bin width in the histogram, while the bar chart has spaces among bars. As you can see here, you will see that the flipper length ranges from 172 to 230. You can see that the most flipper length ranges between 185 to 196. And what are the various components of a histogram? The first one is known as bin limit. And bin limit is just all this, as you can see here, is from, we have some intervals which are just 10, as you can see, from 170 to 180, from 180 to 190, from 190 to 200, and so on. You can see that each of the bar has like 10 widths or bin limits. Another component of a histogram is what is known as count or length, and this is what we have here in the y-axis. Then you can also use color, to beautify it better. Although the color there doesn't show anything, only that it beautifies your histogram. And if you compare your color with what is in the bar chart, you will see that the color, identify different species, because here we have many species. While in the histogram, color is just used to beautify it. Another visualization that we can use to represent our data is known as scatter plot. Some people also call it scatter diagram. What does it do? A scatter diagram shows a relationship between two variables. As you can see here, in this diagram here, we are showing the relationship between B depth and B length. And as you can see, these are the points, of each of the B depth and B length all together. A scatter diagram also has some components. The first component is known as x-axis, which will be displayed here. While the y-axis will be on this side here, sometimes you can call the x-axis horizontal axis, while the y-axis here is also known as vertical axis. You may also want to, display shape. For example, here you can see that each point is represented by a small circle. As you can see, there are many small circles here. Some people also use a plus sign to represent data points, and that is what shape is all about. As you can see here, I represent all these data points by using blue color. As you can see, here is a blue color, as you can see. And if you like, you can change the color to yellow. Whatever color you like is also possible to use. And you may also want to use size. But don't worry about all this. You will see all of them when we start using Seaborn to do it. Another chart that you can use to represent any categorical variable is called a pie chart. A pie chart is the sectorial representation of your dataset. For example, as you can see Adeli here, so this sector represents Adeli, while another sector here represents chinstrap, while the remaining sector represents gentoo species. And one component of a pie chart is color. As you can see, we are separating each species by different color. For example, the blue color represents Adelie, while the green color represents chinstrap. The orange color represents gentoo. And one thing to note is that you don't use a pie chart when you have more than 5 different levels. As you can see, this one we have just 3 levels of species, and they are Adelie, chinstrap, and gentoo. Anytime that your level is more than 5, please don't use a pie chart. Instead, you can use a bar chart. Another visual that you can use to represent your categorical variable and a continuous variable is known as a box plot. Sometimes they call it box and whisker plot. What is box and whisker plot? A box and whisker plot represent variation among your categorical variable and a continuous variable. So which means that when you are using a box plot and you want to show how the categorical variable is related to a continuous variable, you may want to use a box plot to represent that. Now, let's see various components that is available for box and whisker plots. The first one is known as x-axis, as you can see it here. This is where you will put your categorical variable. And the other component is known as y-axis. This is where you will put your continuous variable. And let me explain it clearly. You can see that lily species has more sepal length than other species. As you can see, its own box plot is a little bit higher than the others, as you can see. Now let's see what are all these. The first thing here that you can see for every box plot here is known as the minimum value or the minimum point. While this line here is known as the first quarter. This middle one here that you can see here is known as the median data point. While this one here is known as the third quartile, while this is known as the maximum value of the data point. And sometimes there may be some outliers, which are this, as you can see here for lily. There is also outlier for rose, as you can see it here, outlier here. That is why whenever you want to examine whether there is a outlier in your data set, you may want to use box plot to show that. Let's see another visual, a line chart. What is a line chart? A line chart is used to see the trend in your data set. A line chart always have two variables. The first one will be the time variable, which you want to show according to the time. While the second one here, which is the y-axis, will be your continuous variable. You can also use color, to beautify it, as you can see. And the good thing about a line chart is that it will tell you whether there is a growth across the time. As you can see it here, this is COVID-19 in Nigeria. And as you can see that COVID-19 cases is increasing according to the time. As you can see, from February to March to April and so on, as you can see, it's just growing higher and higher and higher. You can also use size, which is the thickness of your line chart here. Now let's see various packages that are available for data visualization. In Python, there are many packages that are suitable for data visualization. The most common one is known as matplotlib. Matplotlib is good whenever you want to visualize a quality data visualization. One good thing is that many advanced data visualization packages such as Seaborn, which we will see later, they are built on matplotlib. So I will advise you to master matplotlib. And this module will actually show you how to use some of the matplotlib functions. Another package that is also available for data visualization is known as Seaborn. Seaborn is actually good when you are working with data frame and you want to plot one or two variables. Another data visualization that is also available in Python is known as Plotly. One good thing about Plotly package is that it's always good for interactive data visualization. Then we also have pandas. As you know, you've been using pandas since. We can also use some functions in pandas to visualize our data. One good thing that I want you to note is that this module will only show you how to visualize your data by using matplotlib and Seaborn. In summary, I have shown you many reasons why you must master data visualization. So let me represent all of that by using this diagram. As you can see, the first thing about data science is that you collect data and then you process your data by cleaning it, and then you start using different exploratory data analysis to visualize your data set. And in CS31, you will now use machine learning to build different models so that it can be good for prediction. Welcome to the practical session of data visualization. In this video, you will see how to visualize your dataset. Remember, before you start doing anything, you have to install various packages that will be useful in that project. So in this case, I will be importing NumPy, Pandas, Matplotlib, and Seaborn because we'll be using Matplotlib and Seaborn all together in this video. So I run it. Now that we have loaded our packages, let's see how to import our datasets. In this case, I will be using a dataset called Food Service Tips dataset. This is data from Nairobi, Kenya, in which anyone that comes to the restaurant is giving those restaurant attendants a tip. You like tip, right? And let's see what you can get from this dataset. This dataset has various columns such as total bill, which is the cost of the meal in Kenya shilling. Tip, that is a gratuity in Kenya shilling. Gender, male or female. Smoker, whether the person that comes to the restaurant smoke during the meal or not. We also have day, which is the day of the week at which they do that party in the restaurant. And the time. Time is the time of the day, whether it is during the lunch or dinner. And size is the size of the party. So let's load that dataset. That dataset, as usual, is stored in the dataset folder. So I'm going to run it and save the result as tip dataset. Then you may want to see how the dataset looks like by calling head attribute. Now you can see how it is. You also want to see the tail. These are all the exploratory data analysis. You can also see the columns, how many columns and what they look like. Remember in the previous video, I showed you how you can do all this automatically by using Pandas profiling. In that case, I will importing Pandas profiling by using from Pandas profiling import profile reports. And that is what I just did here. And remember, we will be taking a function or an attribute called profile report. So I will be calling profile report on the tips data. So if I run it now, I will get various data exploratory on this data set. I'm still waiting for it. I'm still waiting. Now I have the result. As you can see, we have a lot of reports such as overview, the variables that are there, and their visualization. As you can see all of that. Since you know how to work with pandas profiling, I will not spend more time on this. In this video, we will be using Seaborn and Matplotlib together. And at times, you may want to set the themes of that Seaborn. So Seaborn has several themes such as dark grid, white grid, dark, white, and ticks. I prefer white grid. I am using sns.setStyle to set it. Remember when we were importing the Seaborn package, we used Seaborn as SNS. SNS is the alias for Seaborn package, while PLT is a alias for matplotlib.pyplot package. I hope you get it. Thank you. So let me go back to where I was. Now we'll be using various Seaborn attributes to plot our data set. So the first thing is How do we plot a scatter diagram? Remember in the last video, I showed you what scatter plot looks like. Remember, when you are plotting scatter diagram, you must specify your x-axis and your y-axis. And Seaborn will also help you to do that. For example, we will call sns.redplot. Redplot is for scatter plot in Seaborn. And we will specify our x-axis and our y-axis. Imagine here I say x is equal to total bill. Total bill is a variable on my data frame, and you have to put everything in quotation since that is a string. Remember, we also have y, so you specify your y-axis. In this case, my y-axis is here while my x-axis is here. For my y-axis, I will put tips because tips is what I want to put in my y-axis. Then there is one argument in Seaborn called data, and that is where you will specify the data frame that you want to use for this data visualization. So if you run this now, you get this plot called scatter diagram. Now you can see the relationship between a tip and total bill. Now you can see that here there is a positive relationship between tip and total bill. What does that mean? It means that when the bill increases, then the tip will also increase. Now let me show you how I did it again. So I call CNS. CNS is the Seaborn module, and the function of Seaborn that will help us plot scatter diagram is called relplot. RELPLOT. Alright, and you specify your x-axis, you put the variable there, you specify your y-axis, you put the variable there, and you also say that data is equal to, data is an argument in which you put your data frame into. Now I have the result as this. Isn't that interesting? You can see it looks good, doesn't take more time, and it's very easy to understand. One of the good things in data visualization is the ability to change the axis name, either the x-axis, the y-axis, the title, and all of that. So we'll be using matplotlib functions to do that. And for example, to change the x-axis, let's say you want to change the name, you can use plt.xlabel and you specify the name that you want to put to it. For y-axis as well, you will use plt.ylabel, and to change the title as well, you will use plt.title, and plt is taken from matplotlib package. Now let's see how we can modify this so that we have a better axis name. So let's see it. So here I have the same thing, SNS red plot to plot my scatter diagram. I specify my x-axis, I specify my y-axis, and for the data, I put my data there, which is my imported data frame called tips data. And I'm changing the x-axis to be total bill for the mail, while the y-axis is changed to tips given in Kenya shilling. And also for the title, like I want to give it a better or a good title. Now I call it tips versus total bill. So if I run this now, you can see that I have everything well defined. I can easily read, oh, this is total bill for the meal, that is the amount of bill for that meal. And here is the amount of tips a particular person give after the meal. And you can see the title of our scatter diagram. Let's see important note. You can see that when you are visualizing it, you are seeing some unusual text, like something that is not meaningful to you. So to ignore that, you are going to put a semicolon after the last line of your code. So in this case, I'm putting the semicolon here. If I run it now, you can see that there is no comment again, and I can see my data visualization clearly. Let's see another plot. This plot is called scatter diagram, and in this case we are also putting a line under it which we call regression line. It's almost closer to what we have done here, but we want to show the line called regression line just to see the relationship between the two variables. And in that case I will be using a function called lmplot. This lmplot is also from SNS or Seaborn package. So in that case, I will say sns.lmplot. I will also specify my x-axis, which is total bill, specify my y-axis, which is the tip, and call the data frame into data. Then you remember the semicolon here is to remove all the unwanted comments at the top of my figure. So if I run this now, as you can see now, I now have that line, which is called regression line. And one other thing about this is that you can see something like a gray line here, which is the confidence interval. If you want to remove that, you can just specify ci is equal to none. That is, don't give me any confidence interval. And in that case, I will have something like this. So if I run it, as you can see, there is no longer any confidence interval again, and we now have precise line under our scatter diagram or scatter plots. Let's see another example of visual that we can use to represent our data. In this case, I will be using what is called peer plot. Peer plot is, is trying to give us different plots that will be suitable for our data frame. And what that one takes is just your data frame. You don't need to specify your x-axis or your y-axis. What you need really is your data frame. And to use peer plot, you will call sns.peerplot like this, and you put your data frame inside it. Now if I run it now, as you can see, it's running. Now I have everything. Here is total bill, histogram. Here is total bill and tip. As you can see, this is tip and total bill. So you're just trying to pair those plots together. All right. There's another plot called joint plot. What does it do? Joint plot is similar to that of scatter diagram. In that case, we want to show the scatter diagram alongside with every variable. So every variable will have a histogram. As you can see, here is a histogram, here's another histogram, and now we now see the scatter diagram which represents the two variables altogether. So let me run it. And to do that, you are going to call sns.jointplot. You will specify your x-axis, specify your y-axis, and your data frame, and then you run it. As you can see, now you can see the histogram of total bill, you can see the histogram of tip, and you can see their relationship. This is mostly common, when people want to show the relationship between two bivariate variables. They will just do something like this. This is important because you can see the individual distribution alongside with the scatter diagram. I hope this video is becoming more interesting to you. It's actually very easy. Let's continue. Another one that we can also see is histogram. Remember, a histogram is used to represent a continuous variable. Now let's see how we can plot a histogram. To plot a histogram, you will use a function called sns.histplot. In that case, you will now specify the column that you want. Remember, here we don't have y-axis. So what we are doing here is that we call our data frame, which is tips data, and we now call the column that we want to visualize. In this case, it is total bill. All right, and you may just remove this. If I run this now, as you can see, I have the histogram like that, as you can see now. So what is it? Your x-axis, and you call the variable that you want from the data frame. So imagine I change this guy to tips, and let's see what will happen. So if I call tips on here, I will have this. Oh, I'm getting an error. Let's call it tip. Now you can see this is for tip, and I've shown you how that of total bill looks like. So here is total bill, and the histogram is like that. Sometimes you may also want to show the density distribution on that histogram, and this is how to do it. So what we do is to specify KDE equal to true. The first thing is to call the sns.isplot, call the x-axis and extract your variable into it, which is tips data, total bill, and then call the argument KDE equal to true. That is, give me the density plot of my histogram. And if I run it now, I now get the answer. As you can see now, I have the good output now. So let's see another one. In this case, I want to use what is called box and whisker plot. Remember, we can use box and whisker plot for continuous variable. In this case, I want to see the distribution of my total bill. Now, I have it y-axis, okay, and you call the data argument into it. So if I run it now, I have the box plot here. I can see, as I said before, this is the minimum, this is the first quartile, this is the median, this is the second quartile, this is the third quartile, and this is the maximum. While all the points here represent the outlier, that is extreme values or unusual values in this variable total bill. For box plot, you just say sns.boxplot and you specify your y-axis and the data set that you are going to use for plotting this. Sometimes you may want to show the box plot in an horizontal manner. In this case, you can just specify x-axis to be your variable. Remember, for the previous one, we have it in this case, we have y is equal to total bill. And then because we want to show it horizontally, then we now change our y to x. Now as you can see, it is now being plotted horizontally, while the previous one, which has the y-axis, is now represented vertically. You can actually do it either way. Welcome back. In this video, you will see how to plot categorical data by using some data visualizations. I will continue from using data visualization script, the one that you have here. In order to see it clearly, I'm going to close this folder so that you can see it clearly. Now, how do we plot a bar chart? We can plot a bar chart by using cant plot. The cant plot here will help us to visualize categorical data by using a bar chart. How do we do it? The first thing to do is to use sns.camplot, and then you will specify your x-axis, which is what we have here. And the x-axis here will take a variable called day. You then specify your data, that is your data frame, into the data argument like this, and you then have a bar chart like this. As you can see, this is a bar chart that represents the number of days that those people came to the restaurant. You can see Thursday, Sunday, Monday, Saturday, Wednesday, and so on. One thing you can notice in this bar chart is that the number of days are not in right order. As you can see, the first day of the week should be Sunday, but you can see it here that we have it as Thursday. So cant plot allows us to put it in the right context. In that case, I will have something like this. With the help of the other argument, I can then order my weekday in a list. As you can see, it's still the same plot that I have here. I have specified my x-axis to be my day, and then the order of this bar, as you can see. So I have it in this way: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And I put it in a list and put it under the order argument. And then I specify my data frame, which is tips data. And also relabel the x-axis by using plt.xlabel. And in that, I put day of the week so that people can see what this is all about. I also have my Y label by using plt.ylabel as number of visitors, just to know the number of visitors that came to the restaurant per day of the week. Now, if I run this now, you will see that my order of the week is now in the right order. You can see Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And what you can deduce from this bar chart is that people usually visited the restaurant on Saturday. As you can see, Saturday has the highest bar with 160 visitors. That is all about count plot. Count plot allows us to plot categorical variable. Now let's see what bar plot is all about. You may be asking, what is the difference between a count plot and a bar plot? In symbol, there is a difference between this count plot and a bar plot, although they represent the same thing. But the difference between a count plot and a bar plot is that under the bar plot, you have to specify the y-axis. But in count plot, you don't need to specify the y-axis. Reason is that count plot will automatically display the frequency of that categorical variable for you. Now, before I go to the bar plot, let me show you what I'm talking about so that you can understand it clearly. I'm going to create a new cell under this place, or let me create it after this place so that you can get it clearly. I'm going to create a new cell in this place, and I will call my tips data my tips data. Okay, then from there, let me say day of the week. Okay, by using this, and I call the variable the column of this and call it like day. As you can see, day. So if I run it now, see what happens. I have several, Thursday, Sunday, and all of that. And to get the frequency table, remember I have to use value count. Just say dot value count, the one we saw in the last video. Okay, if I run this now, you can now see the day of the week and the number of visitors that attended that restaurant. And this is exactly what this bar plot is doing now. You can see that here we can specify our x-axis, and the y-axis will now be the total frequency for each day. But count plot has done that automatically for us, and that is the main reason why we will no longer specify y-axis in count plot. So now let me show you how the bar plot works. For the bar plot, we are still plotting the bar chart for the categorical variable, and in this case we are also using the y-axis under it. To use a bar plot, you are going to say sns.barplot. Then you now specify your x-axis. In this case, it is called smoker. The y-axis here is called total bill, and then you specify the data, which is our tips data frame. So let me run it. Now you can see that smokers here, you can see the smokers and the amount of total bill they pay during the restaurant, or during the meal rather. Now you can see that those people that smoke, as you can see, they have more money, or let's say that they have more total bill compared to those people that did not smoke. That means that people that smoke, they paid a lot of money, maybe they ate a lot of food compared to those people that did not smoke during the meal. You can also see that we have a line here. So this line is called error bar. You may also want to remove it if it is not necessary for what you are doing. So to remove the error bar, you can specify Ci is equal to none. The Ci here means confidence interval. So if I put Ci equal to none and I run it, I now have a bar chart that doesn't have any error bar. I hope you understand it, right? It's actually so simple. Let's see another example. In this example, I want to show you how to plot a pie chart. Remember that a pie chart is a sectorial representation of data sets, and that variable must be a categorical variable. So one thing is that we don't have a pie chart under the seaborn. In that case, I will be employing pandas data visualization to be able to plot a pie chart. Now let me explain how to do that for you. Remember that you can extract a variable from a data frame by using all this. Let's say I want to know the gender distribution. Okay, I can get it like this. I can see male, female, and all of that. And to have a frequency table, I can just say dot value count. Dot value count. As you can see, dot value count. Alright. So now if I run this now, I now have the frequency distribution by gender. Okay, so if I want to create a pie chart now, so what I will do is to have something like plot. I can just say another function or another argument called plot. In that case, there is one argument there called kind, and I then say pi. Remember, for every data visualization, you must end it with a semicolon. So I'm putting it here now. If I run it now, see what I have. I now have a pie chart. In this case, I can see the sector for female. I can also see the sector for male. And that is how to draw a pie chart with a pandas. The reason why we cannot use seaborn in this case is that there is no functionality for a pie chart with seaborn for now. Now let's see another data visualization. In this case, I want to plot a box plot. Remember, in the continuous variable, we've seen how to use a box plot to represent our data. And when we also have a categorical variable with one continuous variable, we may want to use a box plot to show the variation among the levels of our categorical variable. And that is exactly what I want to do here. Now, to draw a box plot with seaborn, you can use SNS.boxplot. And then your x-axis here will be your categorical variable. So in this case, it is smoker. And then we specify the y-axis. In this case, your y-axis will now be the continuous variable. So here I have what is called total bill. Then you will specify your data frame by using data is equal to tips underscore data. Then you run it. Now you can now see a box plot. So what is this box plot telling us? The box plot here is showing us that those people that smoke, as you can see, smokers, they pay more bill compared to those people that did not smoke. And that is exactly what this showed us before here, when we were seeing the smokers by the tip, as you can see. Another chart that we want to play with is called violin plot. Violin plot is also the same thing like a box plot. The difference between a violin plot and a box plot is that a violin plot always take care of the outlier, while box plot doesn't take care of outlier. It will show you where the outlier is, as you can see. So it means that a violin plot is robust to outlier, and that is how it looks like. As you can see here, you can see for gender, you can see for female, and you can see the total bill, and you can see how the violin shows those distribution. Before we complete this session, let's see how we can save our plot as an external file. To do that, we'll be using a matplotlib function called plt.savefig. This will allow us to save our plot as an external file, and the external file may be in form of a PNG, a JPEG, or a PDF. So let me show you how to do that. Remember, in the previous session, I showed you how to use SNS count plot, which helps us to plot a bar chart, something like this, as you can see. And what this visualization is all about is that the number of size, okay, that came to the restaurant, for example, we have size 1, and this means that it's up to like 70. And for the size 2, it's more than 200. For the size 3, as you can see, this is the total size for size 3 and all of that. So let's say that you want to save this visual now as a PNG file. To do that, you have this to help you do it. Remember that in order to plot this, before you plot it, you have to at least have a good label. For example, people want to know what is this size all about, or the count all about, and that is why we are having this to help us. For example, the plt.x label helps us to save it as size of the party so that you can see the label here. And also, plt.y label allows us to rename this count as number of attendees. Now, let's say that after you have done that, you want to save this file. Let me first of all cut this and run it. So let's say this is my visual, as you can see. Now, in order to save this as an external file, I can then include this function there, and it is plt.savefig. Fig means figure, that is, we want to save this figure. And to do that, you have to name it. That is, the name you want to save your figure with. In this case, I'm calling it size.png. So this is the name of my figure. If I run it now, see what happens. I have my figure here, but something has happened. What happens is that if you look at my folder here, you can now see the file here. As you can see, the file is here, and I can easily open it. As you can see now, I can open it, and if I minimize my screen and open my snippet codes, as you can see, now I have the file here, which is as a result of what I have saved as an external file. If I open this now, as you can see, I now have my figure being opened without pandas or without anaconda, as you can see. And this now is useful in an external file. As you can see, I can open it, and I can open an MS Word like this, okay, and then copy it there. As you can see now, my MS Word is open, and then I can copy this guy by just right click on copy, and come over here, and then you can paste it. As you can see now it's being pasted, as you can see, okay. Then you can also, as a report, you can just say, let's say this is figure 1, okay. I can say the number of size, number of attendees, the number of attendees that came to the party, and exactly as you can see now. So this is how to save a figure from Seaborn. Okay, this is our figure as well. and let me go to my script. This is it. So let me show you another example before we close this video. Now let's say that I want to plot, let's say I have SNS dot let's say bar chart, bar plot, okay, and here I have x is equal to, let's say let me look at one figure. Like, let me just copy this and let me show you how I can save that as an external file. So let me open more cells. Let me replace this. Okay, you can see now that if I run this, I have this. So let's say I want to save this. I can just come over here and say plt dot save figure. Okay, and then I close the bracket and I call it a name. Here I can call it violin plot. As you can see, I can just say violin plot, violin plot, violin plot dot png. png is my extension. So if I run it now, you can see that I now have my violin plot being saved. So let's look for it. You can see now it's now dropped. This is the violin plot. And if you look at your folder here, you can see violin plot. This is it, and you can open it. As you can see, this is the violin plot. Thank you so much for watching this video. We have now come to the end of CS22. Remember that a programmer must practice every day. And to become a data scientist, you must practice. Read everything, practice every code, and make sure that you participate in the forum discussion and do your assignment. Thank you so much once again, and see you again. Bye bye.